Hello, hello everybody. Just before we get started, just make sure my mic is working. Give me a ping in chat if you can hear me. Um, I assume it probably is. It's my standard setup that I use all the time for my lecturing, so it should be fine. Hey, Michael. It's always a bit awkward doing this stuff over live stream, because usually there'd be a point where I could look around and say hi, and everyone. I'm sure there's a few people here who I've met before and who might know me. But as opposed to what I usually do at CSE, this particular talk is pitched much more at senior students. So I think the people that know me well are the people who I've taught over the last couple of years teaching the first year course. But I think that, as far as I know, Hui sent this out to all the thesis students as a as something that will help people to learn about what to do when you're actually writing technical documents. And it's always a funny thing because, like, anything else that's in a thesis. So, I mean, I would usually do like a hands up or something here who's actually currently enrolled in a thesis, like a thesis A or a thesis B. So just say so in chat if you are doing a thesis at the moment, or you can put an F in chat, and we will all put an F in chat for respect for the people who are doing thesis. Not necessarily, just put an F if you are doing a thesis. That way I can see how many thesis students we have. We've got one from Nathan. We've got about 30 people in here at the moment, so there's would actually normally be a pretty nice kind of little intimate atmosphere here where we'll all just be hanging out and stuff. The way I usually run this, okay, so we've got a few people now saying so. So the way I usually run this would be on a whiteboard with the handout that I've given. If you need the handout, you can just scroll up in the live chat at the moment, because I think even if you joined after the live chat has started, you can still scroll back through. I'm just going to paste it again just in case. Wrong link. That's the link to this stream. So if you want to just double the numbers of people in the stream and watch it twice, you could click on that one. Not as useful as that's not the. No, I copy pasted the wrong link. If you can paste the document link. There you go. You've got a shortened link. That's even nicer. So yeah, usually this would be a much more interactive thing where I put stuff on a whiteboard and stuff like that. But instead, I knocked up some slides yesterday because I'm very prepared and I do things in advance. And so I've got some slides for today that I'll run through, because I think I hit a point where I was like, okay, I've got the handout that I would usually work through, but what I should probably do if I'm going to do this as a live stream is write down a few dot point notes for myself. And I got halfway through that and said, oh, screw it, I've written half the slides, I might as well just write the whole lot. So I've got slides that we're going to go through. If you want to, you can go through the the handout yourself if you want to. I've just got it on my other computer here as well so that I can remember all the things I was going to talk about. So the rationale behind what we're doing today is that actually I've got slides for all of this. So why are we doing something on technical writing? So why do we even have a workshop like this? And I think it's because it's a hard thing to do, and as computer scientists we're generally not trained to do it. So if you're doing a thesis, I would expect that the majority of the coding work that you're going to be doing on your thesis, the majority of the thinking that you're having to do in your thesis ties in multiple subjects worth of work. So if someone was doing a thesis on, I don't know, let's pick something that's close to stuff that I know about, game theory analysis for particular games and how to build AIs to beat these particular games. We're talking about, you've got some programming knowledge, you've got some theory of computation knowledge, you've got some how to build particular artificial intelligences, you need a significant background in graph and tree structures and stuff like that. All of this stuff is taught, and at the end of it, someone points out to you that the marks that you get for a thesis are not actually for the code. Like, no one needs to necessarily look at the code to give you the majority of the marks. They're going to read the research work that you've done, the writing, and so the writing better be representative of the work that you've done. Only there are a total of, I think, 0 courses in CSE that are entirely dedicated to how to write a research paper. I don't know if it's definitely 0, but I think it might be. I mean, like, I'm more than happy to be proven wrong in this case, and that there are courses in CSE that are specifically about how to write a research paper. I definitely didn't do any when I was a student here, but like that was like nearly 20 years ago, so it's like sort of maybe out of date. But I assume that there aren't. I assume that even like thesis A, thesis B, you get walked through it by your supervisor, but they're not necessarily going to take you through and chop apart all of the nitty gritty of how to write a research paper. That is pretty funny, just looking at chat right now, how many of my mods are here right now. So this is basically anyone who has tutored for me in the past or is tutoring for me now, and happens to have taken part in the lecture live streams and stuff is there. There's a whole bunch of you with your little blue spanners. Anyway, so technical writing's not an easy thing to do. And I'm going to say technical writing. Like, if I say writing is not an easy thing to do, that's even bigger. So we're not even going to get into the realms of creative writing or prose or anything like that. Like, we're just trying to get a message across in a really, really specific format. In order to be a master at writing, one kind of needs to spend years doing it. In the same way that I wouldn't expect anyone in their first year of programming to be able to deliver something that was like at a world-class standard. I do expect most of you, once you get to your 3rd or 4th year, to be actually reasonably comfortable to deliver things at a world-class standard. But then what we were going to do a lot of the time when we mark thesis students is we're going to mark you at a research standard. So that is a world-class standard. The people who can deliver research papers in the world is probably, like, at most, say 0.5% of the population have that capability, because it's the very pinnacle of academia to be able to publish research papers. And so we'll judge you at that level without having actually given you the training. So what I wanted to do was try to kickstart everyone's training into how to do technical writing. And the way I came about doing this was to think about writing technically not as, here is a way of doing things that we have no idea about, right? Because we spend like 4 years writing code, and then suddenly it's like, okay, you've got 1 week to hand this thing in, write a document. That's not entirely a joke, by the way. I wrote my undergrad thesis in, it wasn't exactly a week. I think it was 11 days. But I think that this is something that I need to say, like, before we even get started and everything. I'm going to say that you should probably do what I'm saying, but not what I do. I've pulled a lot of all-nighters even just to get assignments released for students, and I feel like that's probably not the best way to go about things. I'll talk about that more later when we talk about, like, last-minute approaches and stuff like that. But what we're trying to do here is I'm trying to leverage the skills that I think you already have. So I'm assuming that everyone has the skills here to write a certain amount of code and put together a program, or even just think in that technical way. So what we're going to do is we're going to break down how to write a technical report / paper / research thesis, this kind of research specific writing, and we're going to break it down in a way that allows me to teach this exactly the same way I teach people how to program. So that way, hopefully, it will become very, very familiar to you, because like a lot of these steps in this process are going to look like a software development process. So I'm going to give you this in the same way that someone might give someone a Hello World program and show them the bits of it and how it works. And then I'm going to show you a step-by-step process of piecing it together. And I'm going to like go to this little point here. This doesn't have to be the way that you do it. This is the way that I found is really easy for people to do it if they don't want to learn the the absolute nitty gritty of how to do it. Like when I was actually working in research, it was really funny because there's all these weird things that seasoned academics knew how to do to get a research paper released. Um, there was at the time I was doing it was really funny. It was like just put the word cloud somewhere in your paper, even if you didn't use the cloud for anything, because cloud was the buzzword at the time, and then more of those papers were getting published. Um, and there were other things about never end a paragraph with only like a third or a quarter of the line there. So there's all this white space because that white space could have been filled with words. So you would fill out the paragraph to make sure it got to the end. And Michael's saying put Bitcoin in your paper. I think blockchain is something that might get you a slightly better chance of being published now than previously. If we go back a few years, it would have been deep learning. You put deep learning in it and then you get published. But I'm not sure. I'm not sure yeah, Arthur saying say blockchain in a mirror 3 times and investors will appear. Um, you're not so far from the truth, Arthur. I have a lot of links with the local game industry, and there's like one company that's doing really well because they have blockchain in their games. So they got investors where like all the other games that are just purely for entertainment didn't quite get the same level of investment. So it's pretty funny. So anyway, what we're gonna do today, I've scheduled 2 hours, but I'm I'm gonna be fully honest with you. This is like a Mark Chi 2 hours, which now that we've gone into online teaching and things like that, and I don't get kicked out of my lecture theaters at the end of the 2 hours, this could go for 3. Not gonna make any promises because if I find something interesting that I want to talk about, I'm going to talk about it. Yeah, I mean, I'm sure some of you are studying blockchain at the moment, right? Let's have a show of emojis for anyone who's doing a thesis in blockchain at the moment. Because I would love to learn about it. Blockchain kind of appeared after I stopped studying, so I have this kind of from a distance idea. Oh, Tammy's doing it. Yeah, so I've got this from a distance idea of what blockchain is. I understand the overall concept. I have no idea how it's actually implemented or anything. Um, Sam, don't know if this will be useful for a first year, but you miss me. Aw, thanks, Sam. That's very nice of you. And Paris said they also miss chicken. Um, okay, so let's not go too deep into blockchain because I will be out of my depth pretty much immediately. I probably won't even define it correctly if I try. So what we're going to talk about is how to put a research paper together, and I'm going to do it as much as I can like an algorithm. So I'm going to bring as many parallels as I can from just the software development. I don't think even people even call it the software development lifecycle anymore, but the idea of at the nitty gritty level, what we do to build a program from start to finish. So we figure out what we need to do, we do a bit of specification and design, we do an implementation and testing. We can do exactly the same problem solving process with our writing. I'm not going to be able to tell you what to write, and some of these things I'm going to gloss over because they're much bigger ideas than what I can talk about. But what I'm going to do is try to give you a framework under which you can get your ideas onto paper so that they're going to work. So, what we are talking about today, just making sure I've got my notes here. First thing we're going to do is going to break down what this research writing is. So there's many options for what this could be. It could be a technical report, research paper, or a thesis. They're all roughly in the same format. Not exactly in the same format, but they're roughly in the same format. So I'm going to break down what makes a scientific paper and what we usually expect to see from it. Some of this stuff is convention, so there's not necessarily rules around it, but there's a convention that's been followed over countless papers and years that we will attempt to follow also. Some of these things are nearly necessary in that if you don't write things this way, people will either refuse to read it, or for something like a thesis, they'll ask you to write it again, or something like that. Especially for PhD thesis, they're either accepted or not. Once you get to that research level, it's not really about marks anymore. It's just about, did you do interesting research or not. I'm not going to go too deep into research. I think that would be a whole nother. It's not 2 hours. It's probably about 100 hours. How to research? It's like, oh well, let's talk about the growth of knowledge in the human race in general, and how we even do that. And we're not even going to go into that, right? But we're going to talk about what the paper is, and then we're going to talk about how to read them. Thesis students will know about this already. If you're in the standard timeline at the moment, you're already into your second thesis subject. I don't know how strict the timelines are at the moment with things, but I think the standard is one subject each of the three. It's just changed recently, so I don't even know how it works. But I think it's one subject each of the 3 terms that you're doing your thesis during, because it's usually meant to span a year. And the first term is mostly reading. Second term is like a lot of work, and third term is writing. I'm really kind of very, very vague brushstrokes over this. I think for a lot of people, it's first term, it's doing these other subjects. Second term, it's doing these other subjects and panicking a bit. Third term, it's coming up with an idea, coding the entire thesis, and then writing it just before the deadline. So we know, your lecturers were not born yesterday. We know exactly how most students are going to achieve what they do, because we were the same. I mean, every now and then we meet people who get work done early and they finish things before their deadlines. I tend to try to hire them to do my work for me, but otherwise, your general human being is not really going to work like that. But anyway, I don't want to too much push the idea that you can do that, because it's possible, but it's probably not a great idea. So we're going to talk about how to read research papers, because it's a funny thing. Anyone who reads regularly, like if you read fiction regularly or something like that, you'll have a particular approach to reading. You'll set aside some time, you'll focus on it, and you'll read and stuff like that. I'm going to give you a slightly different technique for how to read research papers. And I hope that technique resonates a bit with programmers, because it is very much a programmer way of thinking technique. And then we're going to look at what the order is that we should write things in. So this is something this is where we get down to the real technical stuff about how to write a technical report, is that when you first get given the idea of a thesis and you go, okay, how do I even write this? You don't know what to do, right? You go, okay, do I start from the beginning and I start writing, or do I write certain bits before other bits? I'm going to give you an order that might work. I'm not going to guarantee it's going to work, but I know that most of the time it works, because it's based on a logic of what you could know before you know other things, and what you can write based on what the purpose is for each part of the document. So this is all going to tie in together, right? We're going to deconstruct the document, learn how to read them, then learn how to write them. How we decide what we're going to write is a much more difficult one. I'm not going to answer that question fully, because deciding what you're going to write depends on what you're writing it for. But I am going to talk a little bit about figuring out what the purpose of your paper is, because if you don't have a purpose for it, then you don't have anything, in a sense. So we'll get into that as well, and then we're going to get even down to the lower level. So this is like, what is a function, and how do we write a single function? Like, why do we write a single function, and why does it appear in our code? We're going to do the same thing with a paragraph. We're going to break down a paragraph into its like definition, inputs, outputs, declarations, and like what I'm trying to do is like teach you writing in English if we were to treat English like a programming language. And so this is not English in general. This is English for transfer of scientific knowledge. So if you want to, you can follow what I say in a really, really formulaic way. If you want to, you can just be like, yeah, we're just going to do exactly what he said, and that's it. We'll just do that. But if you want to, once you get into it, you can be like, all right, it doesn't have to be exactly like this. We can change things a little bit. Like I've always done that, where I start off in a format that's really easy, and then I read through and see how it goes. And here at the end is like, how do we actually read our own paper? How do we make sure that the first time someone reads it, they actually understand it? So that's the breakdown of what we're going to talk about. So might as well get into this and start thinking about what pieces make up a technical report or a paper. So imagine you have not learnt a programming language before. One of the first things you're going to want to look at is a hello world. So a hello world program is just going to give you the super basics. Like, how does this language start up? How does it run? What are the basic pieces that make it work together? So it's like, does this language have bracketing? Does this language use semicolons? Does it use indenting? Um, does it have particular syntax that it uses? And so this is the general layout for a research paper. We will have an abstract. One of the most difficult things that I think for people who have never read papers before, and especially people who have never written papers before, is what is the difference between the abstract and the introduction. I'm going to go over this in detail later when we talk about writing them. In the time it makes sense to write them, I'm going to talk about this, but I do want to at least leave you with the one-liner notion of what each of these things are for. The abstract is the TLDR of the paper. TLDR, I'm sure most people already know, but it's an acronym that stands for too long didn't read. There's a reason why abstracts, when papers are written in a business perspective, when they're like reports of business projects and things like that, they call them executive summaries. It's the same thing, and it's for an executive. So for example, let's say this is me, I'm high and mighty executive, I'm running a company and I have like 20 different departments all reporting to me each month about what they're doing. If I was to read the entire reports, I would not get any other work done. So what I do is I read the summary that's written for me, the executive summary that says, this is what we did, this is why we were doing it, these are the results. And so what I can do is I can say, yeah, I know absolutely everything I need to know in that paper because they told me what happened. They told me why it was written and what happened. And so that's cool. And so what I can do is, like, after reading the abstract, I can decide if I need more detail or not. If I don't need more detail, me as an executive, I can just tick it off and say, yep, job was done, I trust that they did it. This flows into what I'm going to talk about next, about reading papers. It's really easy a lot of the time from reading the abstract to tell whether you need to read a paper or not. Because you can just see whether it's in your subject field or not based on the abstract. The difference between the abstract and the intro is interesting, because the introduction is not there to give you an overview of the whole paper and everything like that. Instead, the different thing that the introduction does is the introduction is there for a purpose. It's there to give people everything they need to so that they can read the rest of the paper. So it's kind of like what I did here, where I have spent the first 3 slides saying really specifically and talking about it and stuff, why you need to be part of this workshop. You know, like, so I said, this is what this workshop's for, this is what I'm trying to do, this is how I'm going to teach it. That's what an intro is. An intro prepares someone to read the rest of the paper. So that's why here we have in the brackets here, background. Sometimes this is a separate section, sometimes this is just put into the introduction. If you're doing an honors thesis and you're going to be writing, I'm going to ballpark it here, 50 pages of stuff, then your background is going to be separate to your introduction, because it's going to be like, you know, at least like 5 or 6 pages worth of, like, this is the field we're in, this is how it works, you're going to explain it all, and then you can then show how your stuff launch pads off all the rest of the stuff that exists. If you're writing a research paper and you're squeezed into 6 pages for the conference proceedings or something that you're presenting it to, then your background has to be squished, and it just ends up being a whole bunch of citations, just going, look, I don't have time to talk about this, I want to talk about my own work, read this other stuff instead. But either way, the same thing happens where the introduction is still going to give people a chance to figure out what they need to know for the rest of the paper. The chapters are your chunks of information. Each chapter has a specific purpose depending on what you're writing. So if I've done a research project, my chapters might look a little bit like this. I might start with a theory chapter saying, my idea is that if we link together nodes in a graph in this particular way, and then we use this particular algorithmic structure to move between nodes in the graph, we can explore the graph in a more efficient way than has been seen in these other papers. These other papers explored the graph in these ways. I explore the graph in these ways. It's more efficient. I've solved NP hard. Give me a Nobel Prize for science and stuff like that. You may not necessarily be doing that. It may be impossible to solve NP hard, and we may never do it until quantum computers give us a different type of hardware to solve it. Anyway, let's not get into that too much. Yeah, I think Michael is, just linking the paper again there. So I can say, okay, this is the theory of what we're going to do, and then we can say, all right, then we ran it. Then we ran it on these computers, and here's a whole bunch of graphs that show the evidence of the changes that happen over these particular data sets, and this is why these data sets make sense. Here's our statistical analysis of this kind of thing, which is then summarized in our results here. So this kind of flow is reasonably common in papers that are talking about work. So if you've already done a lot of work, and this is definitely relevant, I think, for thesis students, you've done a lot of work yourself, and you need to present it in a way that makes sense, you'd split it up like this. You get other research papers that are completely different. Sometimes a research paper is a review of a field. So it says, if no one knows about this particular field, I'm trying to make up one, developing human-centric game controller devices. And then we could have stuff here saying, okay, ergonomics is important for this reason, the number of buttons needs to be important for this reason, accessibility versus the level of expert control and stuff. And so all of your topics are going to be a bit different there. And they're going to analyze these things and look at the history of how it works and things. So it might not always be theory, implementation, results like that. But I think for a lot of people doing a thesis, you'll find that your chapters will naturally split themselves up like this. We're going to talk about all of this in a little bit more detail as we go through. The conclusion is going to piece together everything here and say, okay, given all this information we found out, such and such, and then your references. I'm not actually going to talk that much about references because I don't think anyone needs to learn how to do references. References are a rules-based system. There are very specific rules if you want to follow Harvard referencing or MIT referencing or whatever particular referencing system. What I used to do, and it wasn't that long ago, so I'm assuming people are still doing the same thing, is every paper I read got put into a program. I was using this one called Mandalay at the time. I don't know if people are still using that, but every time I read something, it went into that program. So that way later on when I wanted to reference it, I'd just like basically type in a number in my paper, and the LaTeX referencing, the LaTeX hook into the referencing system. I think it's Bibliotech. I can't remember. I'm going pretty deep into technicality there, but that kind of thing. I'd be able to type in a number, and the paper would just show up and be referenced. So if a computer can do it for us neatly, then that's not something I really need to teach you. But I'm going to teach you how to actually form the English so that it works in a way that we end up with a report in this format that gets us there. All right. I'm jumping ahead, actually. There's a lot of stuff there that I am going to talk about in more detail than I have there, but there's some of the ideas coming up. I should point out one thing that comes up a lot when you're teaching people things, and this is something that you have to understand if you're going to write a research paper, you're teaching someone something. Because what you're trying to do is, in a document that you can pass over to someone else, you want by the end of the time they've read the document, does that make sense? By the end of reading the document, they have learnt something about what you what you have done or what information you want to give them, which means what you are doing in a sense is teaching them a lesson about what you are doing. So what we do when we're teaching is we have this hilarious thing that, like, humans don't hear something the first time. Well, they don't really understand something the first time they hear it. So what you do is you present what you're going to you tell them what you're going to talk about, and then you talk about it, and at the end you talk about what you talked about. And it's really funny how you can see this here. In the introduction, you talk about what you're going to talk about. If someone reads the abstract and then the introduction, they're going to get a double whammy of that. Because the abstract says what the paper's about. Then the introduction says what the paper's about. And then you actually say what the paper's about here in the chapters, linking everything back to your points. And at the conclusion, you say, all right, this was what the paper was about. So if you look at it in this sense, it looks like, the majority of the content is just, this is what this paper is, and you just repeat it over and over again. In reality, the chapters are much bigger, and a lot of them are like, okay, here's a small part of it. But yeah, so this is me also doing the same thing in the talk, and so you can sort of deconstruct not just how a research paper should go together, but you can use my talk as a deconstruction of how you would transfer information to a human. So for the moment, I've just done this big overview of what a research paper is, and now we're going to break it down into little pieces and show you how each of these pieces puts together and what their purpose is. And then that way you've got this overview of it, and then you've got this tight view of individual parts of it, and then hopefully you'll have the ability to piece them all together. This is exactly the same as how we write a program. We think about what is the entire purpose of this program. So we want to create something that chains blocks together. Sorry. I have no idea how blockchain works. I think it chains blocks together. Say the keywords. Try to sound intelligent. So yeah. I'm not gonna continue. I've just completely broken my own train of thought by trying to pretend I know what blockchain is. So we're gonna move on. We're gonna go back to the paper itself, right? So we've talked about what it is, and then we're gonna go through. But this time, when we go through, we're not gonna go through in this order, because this is most certainly 100% not the order that you write it in. So we're gonna go through this thing in the order that you write it in, and we're gonna look at each of the pieces and how they fit together. Well, Arthur said that's the gist of it, so I'm just going to assume, because I don't think I know you, Arthur, that you're an expert in blockchain, and so you're confirming that what I said, blockchain chains blocks together, is correct. And I'll get away with it there. Okay, so, but before, now that we've sort of deconstructed what the paper is, let's think about the thing that you need to do before you can write a paper. So before anyone writes a paper, they're always going to read a few, because it's pretty hard to write something if you've never read anything like it. It would be like trying to write a computer program without any notion of how a computer runs, or having never actually run a program before, and suddenly being able to write one and not knowing why or what a computer would do. So so Arthur said, please don't assume that. So I think that Arthur probably knows a little bit more about what actually happens in blockchain. Oh no, are you saying please don't assume that you actually know about blockchain? Okay. I have a feeling that, like all other buzzwords in computing, no one really knows what's going on, but everyone's trying to figure it out. Like, I remember when data science became a buzzword, and I was talking to academics from a French university, and they said, so what we did is we took our computer science degree and we made a carbon copy of the computer science degree. It's exactly the same degree, and we named it data science, and we put it up on offer. And I was like, what? And then when it came down to it, we talked about it for a while, and it was like, oh, you mean data science is just computer science, but just a slight focus on analyzing data, but all the skills that you need are the same. And they're like, yeah, if you've got a computer science degree, you can start doing data science, because who do you think started doing data science first before there was a degree? I was like, okay. I mean, I'm sure it's more nuanced than that. I should probably not say that. I'm sure it's much more nuanced than that. You're going to need to know some maths and stuff like that as well. But let's look at how to read. I just loved having this title because I was going to put this more detail, how to read a research paper, how to read something technically, and I thought it'd be funnier if I just said how to read. Um, and the subtitle here, if you can read this, you can read. So hopefully we've got the basics, right? I don't expect people will reach a point where they could write a research paper when they don't have basic literacy. So this is the thing to check if you have basic literacy. If you can understand what these two sentences are, then you can go on to eventually understand research papers. There is an art form to reading research papers, and let me tell you the way that I used to do it. I don't do much research anymore. My time is entirely consumed with teaching nowadays. But what we would do is we would like have a really wide kind of shotgun spread of possibilities. We would just download, 20 papers. And downloading 20 papers is a daunting concept because to fully understand a research paper, I would usually want a few days. To fully understand something, I would want 2 or 3 days of delving into this paper. So this is a 6-page paper that you could quite easily read in like 20 minutes, half an hour if you just were reading the words. But to fully understand it takes much longer. But what I would do is I would just read all the abstracts of these 20 papers and throw away at least 10 of them. Because reading the abstracts, you know whether it's going to have something that you actually need or not. And so taking this to a computer science perspective, I would consider it a very poor brute force approach if I was searching for particular valuable information in a piece of data. If I said to you, give me the valuable information in this piece of data, and you said, sure, let's start at the beginning and let's iterate through every single piece of memory for this data until we reach the thing that we need. No, right? We don't use order n solutions to things if we have a choice. You can be like, well, why don't we split this thing in half and find out where we are? Like the standard things that people do first when they're like, we should be doing this in a more optimal way. You should be doing that with research papers as well. Never read the whole research paper unless it is basically the paper that is the one before yours. So you will find that sometimes where someone writes a paper and you go, wow, this is exactly where I start from. So the research I did took this research and then I added to it, and that's what my new paper is. If you find one of those, then you read the whole thing. Super important. If you're doing an honours thesis and your supervisor has given you the topic, because that happens a lot where you talk to a supervisor and you say, I have no idea how to do research, and they say, here's a topic that's going to be interesting. You will have something that leads up to it, because it's interesting to them because they know that there's a certain amount of research that leads up to it, and there's a bit that you can add on to that. Very often this is going to be when you talk to a lecturer at CSE and they have a body of work that's currently in progress, and they say, well, these are the things that need to be extended, which means that the body of work that you're extending just exists here at CSE and you can look at it and things. But otherwise, when you're just like Google scholaring and you're out there in the world looking for papers, you grab a lot of papers that mean nothing to you. And so the way that I would always search through this data is to use a very specific targeted approach. I would look at the abstract first, and I would cull a bunch of papers based on their abstracts because they would be using techniques that I'm not particularly using, and I know that I can't go into that right now. Or the abstract will show that they're actually in a completely different topic from mine. So they may have used some of the same keywords, which is why they turned up in my search, but their entire research is in a completely different direction, so it's not relevant to me. I find the ones that are relevant, and I go through, and I don't read any of the other bits, I jump to the conclusion. So I look at the conclusion and I say, what'd you find out? Because now that I've read the abstract and I know that you're working on a similar thing than me, I want to see whether you had something groundbreaking happening here, or something that led you in a certain direction. And then I can see, ooh, these are leading in directions that are interesting for me to know about. So sometimes it's like, we found out this approach didn't work, and you're like, oh crap, that's the same approach I wanted to do. And so you go, all right, I need to look at this paper. And so you go into the body and you look at the bits that you need in there. Sometimes it's just like, in the conclusion, it's like, yeah, this thing works. And you're like, oh, it does it? And then you go into the body, you look in the results, and you say, okay, I can see how that works. I can see you got a 4% increase in efficiency in certain data sets, and you did not get an increase in efficiency in other data sets, so I can see where the gap is now. I can see where I might want to get involved. The conclusion might also say things like, further work in this subject might include such and such and such and such, and you go, oh good, because you mentioned what I want to do. Sometimes at that point, it's nearly worth even sending an email to the person and saying, hi, you worked on this up to this point and you said some future work might be this. Have you continued that? Um, and like this is what collaborative research is all about. Worldwide collaborative research is like plenty of people, when they receive emails like that, are going to reply. They're going to say, oh, this is really cool, there's someone out there that wants to use my research and continue, and they will open the conversation and talk about what's happening. um, so that's a pretty cool thing that can happen. um, so you don't need to read everything, um, but what I do like to say is that you want to write down notes about everything. And I would definitely do this. I mean, like, some people like to work on paper. I don't like to work on paper. I like to work on digital devices. I prefer my notes to be in a cloud somewhere. Um, you can even write these notes in the same software that you're using to do your referencing, depending on which software you're using for that. It's good to get that kind of setup. But if you write your notes there, it reminds you which papers you need to go back to, and also reminds you which papers you're going to be referencing later. Because one of the worst things that you can do is say, oh, this thing, and this is a concept, and not reference anything. So if you introduce a concept in a paper without a reference, that's implying that you made it up. So it's like, oh, the shortest path algorithm allows me to find a path through this graph that covers the least distance. And it's like, okay, the research for that, we look up Dijkstra's shortest path, is I think 60 years old now, and you do not get to say, oh, there's a shortest path. You should reference it. You should say someone else has already come up with this. This is how you use it. And if you want to, go back and read those research papers. I'm pretty sure Dijkstra's shortest path is like 1960 something. You know, it's like old school basic graph maths. Um, so writing all that stuff down means you kind of know what you're going to reference later, and you're not going to have these empty references where you talk about a concept, and you accidentally imply that you invented the concept, because you don't really want to say that you invented a concept that everyone else already knows and is quite old. So you want to make sure that you give the credit back to the people who did the research that led up to your research. One of the I can't remember who it was. This is back when I was an undergrad student, so many years ago. Someone came to give a talk at CSC, and it was like something that kind of blew my mind at the time. And I think hopefully this helps you when I pass on this kind of idea, is to not treat any of your textbooks like a book. You've got to treat them like RAM. So all of your textbooks are random access memory. They're not things that you read from start to finish. You should be jumping around to the bits that you need in them. I mean, some textbooks are scripted in a way that they go, okay, learn this, then learn this, then learn this. And so you could use the textbook instead of a subject. But if you're using a textbook as a reference for something to learn about things, then you should just be jumping around. Very much. I mean, like, this is nearly something I don't even need to teach you, because I think that nowadays the idea that we would read books start to finish is nearly an archaic way of thinking about things. Like, I'm talking to those of us now who spend all of our time online. We never read anything from the beginning to the end. We jump around, we look at ideas, we see if anyone else has posted something about it. We read the comments section and get angry. So the comment section is the completely uneducated part of this, right? So we don't even need to care about that most of the time. But yeah, but everything that we're looking at when we're already sort of doing this, treating this thing as a block of data that is not ordered, and we go and pick and choose as we need. Michael's claiming that he invented Dijkstra's algorithm, and Sam said, "New algorithm, who dis?" Yeah. Sam, it is Sam's saying that he enjoys reading whole books, and that is totally fine. And I think that's a part of it. And whether you read a whole textbook start to finish. So this was given to me as a piece of advice if you want to efficiently gain the knowledge you need to get stuff done. And that's very different from doing something because you enjoy it. If you enjoy something, making it efficient is one of the ways that you can just kill your buzz. Like, if you want to get like a hobby that you really like doing, and then start trying to do it as fast as you can instead of enjoying it, that's how you turn hobbies into work and destroy them for yourself. But if you enjoy reading stuff all the way through, then totally go for it. Blaze Bogo sort pages of Harry Potter before reading it. Bogo sort, and in what is it? Best case timing, Bogo sort is the best search algorithm out of all search algorithms. It has the potential to sorry, not search, sorting algorithms, right? Bogo sort is the one that, if it's right, it has, is it order one? Yeah, because it just randomizes the entire data set, right? And so order one, it gets it right the first time. Or order infinity because it never gets anything right. Has anyone ever seen those YouTube videos? Because someone brought up sorting algorithms, so you've triggered a tangent now. So there's these videos, YouTube videos online that are animated sorting algorithms, and they have like audio cues for all the things they're doing as they're sorting. They are a lot of fun to watch. The Bogo sort one's pretty funny. It's just random noise. In case anyone doesn't know, the ordering of sorting algorithms is just like this age-old argument for programmers about which one's better, because there's different ones that are better for different reasons. But Bogo sort's one of the best because you just randomize the entire data set every iteration, and then just check if it was ordered every iteration. And so at some point, Bogo sort's going to be correct. And because it's a series of order one operations, I guess. I don't know if it's order one. Randomizing a data set might be order n, but who knows? There's a chance that it's right first go, but there's a chance it's just never right. Blaze is apologizing. It's okay. Yusuf says they like to bring gambling into the sorting algorithms. Yes, that can also always be a lot of fun. Not sorting algorithms, but I actually did a lot of work with Monte Carlo search algorithms. And that's really based on gambling. So it's based on trying to get a statistical picture of things. Anyway, so I love it. We're nearly end of the first hour, and all I've talked about, we've only gotten up to how to read. So let's get back to it. Non-zero chance of order one is the best kind of order one. Well, actually, Nerdy Gamer Geek, that is totally the way, because like when you think about it, there's no other search algorithm that can give you a non-zero chance of order one. Like all the other search algorithms are like, no, we'll give you an n log n or something, but there's no way we're going to say that in order one this will potentially give you the correct answer, unless there's a search algorithm. There's a few of them that can confirm that the list is sorted in order one. Actually, no, they can't do that. At minimum, all the other sort algorithms are going to be at minimum order n to stop running, because they'll at least have to pass through the list once. Bogo sort just clicks its magical fingers and says, "Yep, I think it might be done." Okay, let's not get into that. I think someone else is teaching algorithms, and it's not up to me to launch into that while I'm doing a workshop on something else. Okay, if we've got our reading to this point, we can actually start writing. And so the interesting thing about this part of your paper is the background/literature review. You can actually start writing this before you've even figured out what your paper is. So if you know what field of study you're in, and you know what you've been reading to get to the work that you're doing, you can write your background already. So those of you who are already in the depths of doing an honours thesis will probably know this because you've already written it. So you've got your literature review written already, even if you haven't completed the work that you're doing to add to it, because the literature review is basically saying, this is what exists in the world already, and you haven't even said where your jumping point is from what exists in the world into the new stuff that you're creating. So just a really, really basic idea of what research is. Research is we take the knowledge that has been accumulated by the human race, we find for ourselves the frontier of that knowledge. So the most recent thing that has been created in a particular field, pushing the boundaries somewhere of what we understand. And what we do is we say we're going to push this particular boundary that we found, we're going to push it a little further. We're just going to explore a little further, see if we can find something new, some new information. And that's what research is in a nutshell. I mean, I'm trying to do this without going into like hours of talking about what research is. So in order to know which boundary you're going to push, you need to know where they are. So you need to find your field, and you need to know what's been done in your field, which is why doing something like an honours thesis involves a good 6 months of understanding the field first, before you even kick off into doing anything of your own. So if you're going to create something new, you have to know that it's new. And how do you know that something's new if you don't know the field? So it's kind of like, I don't know, I'm just thinking like if you're trying to break into like the music industry, you're trying to make music, you need to listen to a whole lot of music to see what the current trends are, and you want to create something that no one's ever heard before. So you want to experiment with what the current trends are and shift them into a new way of thinking. You know, you can totally do that, but you're not going to be able to do it unless you know what the current is, and that's what this background is. So all of those notes that you've been writing here while you've been reading, they become the things that you can put in your background section, because these are the things that you needed to read before you can get to work on what you're doing. So long as you needed to read those papers, chances are someone else would need to read those papers in order to get the background they needed to understand what you're about to tell them. So the things that you needed to learn about in order to start working on your thesis or your research or whatever are the same things that other people need to get up to speed. And so you don't need to explain the entire field in the background, but you do need to at least give people the citations so you can say, okay, we're going to be working in such and such field. We're going to be working in blockchain. Citation, citation, citation. We'll be working in this particular part of block. I love how I use blockchain as my demo for everything, even though I know nothing about it. Yes, my internet is definitely crapping out right now. Just gonna make sure that my phone's not doing anything, but that's highly unlikely. 1 second. I'll be right back. See what I can do about this. I think I fixed it. I'm not sure, but I think I fixed it. Because my upstream is now back to my normal level of upstream. How's it going for everyone out there right now? Yep. Okay. My little light's going back from red to yellow green. I'm pretty sure it was this one. My other computer that I'm using as a thousands of dollars worth of piece of paper right now. because it's literally just a piece of. I could have printed out these notes, but I figured I'd use the computer. I don't know whether using a computer to look at documents or printing out documents is better for the environment. I have a feeling that the computer is better. I don't know. Like, if I was going to print out hundreds of pages worth of documents all the time, I think that would be worse. But I think that this computer was was doing some upload stuff, and it was killing my upstream. So I just took it off the wireless, and it should be okay now. All right, my upstream's still not perfect, but I think it's sort of all right. Okay, so we were talking about writing background, and so the background is the first thing that you can write for your paper because you don't even need to know what your paper is going to be before you write it. Thesis students will probably know this because you will probably have had a conversation of some kind with your supervisor, and they would have said you write your literature review as part of your thesis A potentially, or thesis B, before you even get into the later um, points of your thesis. So even before you've done your research, there's a pretty good chance that you've already written a literature review to prove that you understand the field that you're getting into. Um, One of the key things, I'm just going back through my notes here, is that any concept that you'd consider to be like a keyword or anything that has a capitalized name because it's a well-known idea or technique and stuff pretty much requires some kind of reference, because anything that's that well known means someone else made it, and so you need to reference it so that if someone wants to know more about something, they don't need to read your background on it to know more about it. They want to go deeper into something, you've got to give them references to find out more information about it. Generally, for you to know about something, you've had to read about it, which means you already know that the references exist. um, in a small research paper that's only like say 6 pages worth of stuff, your serious background section that really outlines what the field is going to have 10 to 20 references in it. Your undergrad thesis is probably going to end up with more than that because you've got time to really go through and talk about the details and stuff. Um, this is the first point where I've actually talked about writing. So this is the point where I've said, okay, write this stuff down. And I haven't really said anything about how to write yet. What I want you to get into your way of thinking is the way that we write code. So we write code that we think is going to work. We don't know it's going to work. We think it's going to work, but we just write the code. And then we test it and we iterate on it. And we write new code. We modify the code later. Once you just start to treat your writing for research papers or theses the same way. Just dump the words on the page. It is, I mean, like when I say this, I'm talking like an analogy of actually writing with a pen on paper, and I don't think many people are going to be doing that. But when I say dump the words on the page, you can dump them into a word processor in exactly the same way. Don't think about whether the writing is good or not. Done is better than good. Just write something, get your ideas on the page, edit them later. Don't edit them as you're writing, because that's one of the things that really cripples people, is they write a sentence and they go, oh, that doesn't quite read right. Like, it's got the concept that I want to say, it's got the right keywords for what I want to say, but it's just not sounding right. And you go back and you rewrite that sentence, and you start picking at yourself, and you start really picking at it, and then you just sort of like 2 hours later you've written one sentence, and this is something that happens to a lot of people, right? And then you get stuck on that one sentence, and then 3 days later you're like, I really don't want to do that anymore, and then you don't write anything else, and then it takes a while for you to like reset your brain and come back to actually write. So what I'm going to suggest is just dump and write like you speak. So I've got this thing in the in the notes here that says write like you speak. If you can't use big words on paper, then don't. There's no point pontificating over allegories and extemporizing analogies if it's too hard to read. And I was like, yeah, P.S. I have no idea what I just said, so don't write like that. So unless you really do know the words, just write like how you speak. Eventually, you can sort of learn to speak and write in a really formal manner, in a manner that's really unambiguous, that gets the message across really clearly. But in the same way as programming, like you don't expect someone's first program to have perfect style, be ultra efficient and stuff straight out of the box. You expect them to write some random shit, right? Like it's just like why is that if statement there? It doesn't do anything. It's like logically never going to run, and it's like doesn't matter, you know. They got their first program out, and it still solves the problem. Um, it's important to kind of act like that the first time you write something. Because if you want to, you can always go back later and change it. There's nothing stopping you from editing the document later, but it will disrupt your flow and it will stop you getting your ideas out if you start to edit it while it's going onto the page. So just get the thing out. Don't think about it. Don't edit it. Just chuck things on the page. Don't even erase anything. You know, just come back to it later. Sometimes the most natural way that your words went onto the page is actually the most natural way to read them, and it'll come back to you, and you'll read it in your editing, your proofreading later, and just be like, that one's okay. I thought it was really bad when I wrote it, but now that I read it, I fully understand it, and it's like, okay, it stays, you know. And if you don't let those things have a chance, then you don't iterate, and we know that from software development, if we don't iterate anything, then that's kind of the death of our project, right? Because if we're not going to revise things, then we're never going to get better at anything. Sam's saying the same thing. Oh, you're writing a novel at the moment, Sam. That's cool. Are you a combined arts student or something? Or yeah, don't edit as you go. Yeah, I like to only edit things once they're finished. So I'm okay with editing a section after the section is done. But if I'm still in the mode of creation, then I'll just create. Okay. So we're going to start to think about writing. Oh, Sam, you're a commerce comp sci. Right, that's cool. But I mean, writing a novel, you don't have to be. I apologize. You don't have to be an arts degree to write a novel. You can write a novel because you're interested in them. Um, so we're going to approach writing as an algorithm, and when we're creating software, so we're looking at the design process, the engineering process for software. We look at, like, we specify something. I mean, even before we specify, this is really kind of dumbing it down so I could fit it on one line. We would probably want to gather requirements first and figure out why we're doing something before we would get specifications like halfway through the process, frankly. But, you know, we're gonna think about it in a compressed way. We'll specify something, we design, we implement, we test. There's a cycle of doing things, and there's steps that we know. You know, so if we've done any engineering, we know how to go through these steps one at a time. Documents have the same kind of workflow. You're going to read, form ideas, separate those ideas into topics so that you can present them, summarize them. You're going to proofread, then you're going to go back again. Proofreading and reading, similar, right? And so if we follow this workflow, it's going to be reasonably easy for us to at least know what we're going to do next. Because I think that when you're in a confusing field, and I think that writing something like a research paper could be considered a confusing field for a computer scientist that hasn't done research before, because it's not the way that you're used to doing things and stuff. So if we can get it so that you can start to do things in a way that that feel more familiar to you, you can always say, after I do this, the next step is this. And then after I do that, the next step is this. If you can do that, it takes a lot of the worry out of your head about how to create something. So if, for example, I said to you, create me an artificial intelligence that will defeat the world champion at the game of Go. On the one hand, you could say, look, that's already been done. It was like 2 years ago. 3 years ago? AlphaGo? Doesn't matter. It was a little while ago. But if I asked you to do it, you'd be say, that's too big. I don't understand how to do that. But if I said, here is a process that we're going to go through step by step. It's going to take us quite a lot of time to do this. But we do know what we're going to do, or we do know what we're going to do next. we know that we're going to break this thing down into parts, we're going to do them piece by piece, then you'll actually be able to get started. You'll be able to actually do something. But if I throw the whole thing at you at once, it's really hard to do anything about it, and it's really easy to get your brain just shutting down at that point. So if someone said to me, hey Mark, how about in term 3 you teach a subject that you don't know anything about? How about in term 3 you take the blockchain subject? I would be a bit like, how about you don't? And how about I do what I'd already planned to do this year? We do our planning much further in advance than that. But if that was that case, then I'd be stuck, you know. I'd be like, I have no idea what I'm going to do. I'm not even sure how I would start this process. But if someone said to me, we'd like you to give a guest lecture overviewing what blockchain is, I'd be like, okay, I can do an overview, and if it's a guest lecture, it goes for this many hours, and this is how I'd prep it. And then someone said to me, okay, so the first thing we want you to do is do an overview of the slides. So just give us slide headings for 10 slides. I'd be like, yes, I can give you slide headings for 10 slides. I've got to do a bit of reading on what blockchain is first before I can do that, but I can probably do that. And they say, okay, after that, can you fill out some of these slides with information? Then can you do this and this and this? Right? So if we have a process, it's much easier for us to get through it. Cool. Michael's saying this program reminds you of linked lists. Yes. People are saying I should put blockchain assignments in 1511. Not everything I talk about is always going to go into 1511. I'm trying to keep that course actually accessible rather than just here's the entirety of computer science. I'm going to squeeze it into 9 weeks. And yes, this should remind you of linked lists if you've done Comp 1511, because I just use the same kind of slide setup all the time. I hopefully consider my slides to be minimalistic enough that you're just going to understand them without trying to do too much silliness, you know. Okay, so we're going to read, we're going to form ideas, we're going to separate those ideas into parts that we can talk about individually, we're going to summarize it all, we're going to proofread. So this is actually the way we're going to do it. There's a more detailed step-by-step in the notes here that I'm looking at, but I'm not going to go into those details right now, because we're actually going to jump into the actual work. So the question that one must answer in order to write a research paper is, what are you going to write about? And this question could be answered well before the paper is written, because it's like, what have you been working on? So it's like, okay, in the last 6 months of your thesis, for example, what did you work on? Because you weren't just writing the whole time in a computing situation. So this is where we're very focused. Like, I could not give this same discussion to someone who was writing a thesis in the arts, because in the arts it's like, okay, you're writing for a lot longer because you're thinking really carefully about this stuff, and a lot of the work that goes in at that point is actually into the writing, whereas for us it tends to be work goes into a project which is separate from the writing, but we must convey what we've done in the project in the writing, or else the work was not worth it. Well, not worth it, but I mean, like, if you can't communicate what you've done, then it might as well not have happened, because no one will ever know about it, and it will not further the knowledge of humanity. So the writing is the distillation of the work that we've done in a way that other people can use it. I should have opened with that. That was a nice line. See, sometimes you just spam stuff out of your brain, and then later on in the edit pass you go, oh, that was interesting, that was a nice line. And if you're not free to just say what you think, this is when you're writing, then if you constrict yourself while you're writing, you're going to end up squashing some of those cool ideas. So deciding what you're going to research about is much bigger than I'm going to talk about today. So research in general is like, okay, find out what you're going to do. But when we're here and writing our paper, I mean, sometimes we might be writing a paper just for an assignment. So some courses still do have us writing things rather than like just doing all coding project work. We would first figure out what our thing is. So every time we're going to write about something, it's because there's a point, there's a main point that we're going on. So we're going to try to find out what our main point is. In your thesis, this is reasonably simple because it's like, okay, now that I know all of this research that I'm working on, I've found a point that I can add to. So I've looked at all of this research of people doing blockchain stuff. And what I've done is I've said, what if we chain 3 blocks together with one chain instead of just a single chain of, I don't even know, this probably already exists, but this is because I haven't done my background reading. If I'd done my background reading, I would know that there's a gap somewhere, so I'm just making it up as I go. What if you chain 3 blocks together at once? And that is the new tri-chain research. You don't need to make up a buzzword for your research, by the way. Like, it should hold up on its own without you needing to do a marketing spin on it. If you have to do a marketing spin on your research, you should probably question whether that research is necessary or not. Yusuf is telling me that making a block tree probably already exists. Oh, are you saying it already exists? Or are you my marketing team? Nerdy Gaming Geek says it's a blockchain chain. Okay, so some of this stuff probably already exists. Or you're my new marketing team. So let's get a whole bunch of research published on the blockchain chain or the block tree or something. Okay, so that's the main idea. You're going to either have already spent a lot of time working on this, or you're going to try to figure out what you want to talk about this. So this becomes the main reason for your paper existing. It's very, very important to remember this. Your paper exists for a reason, and this is that reason. The reason is you want to present this idea. You don't need to push this idea, you just want to present it. So when we think about this like code, this is like us going back to the original question of why this code exists. So I know that this happens to a lot of us. Sometimes the reason our code exists is because it's cool. So it's like, I wanted to do something because it'd be fun to code it. That does not usually yield good research. I mean, sometimes it does. Sometimes it gets you $1 million of Silicon Valley venture capital funding, but let's please never use that as a reason why we should or shouldn't do something, because Juicero got $400 million, and that's just a beautiful prime example of why getting seed funding doesn't mean you should do something. Does everyone know the story of Juicero? If you don't know the story of Juicero, you should look up the story of Juicero, because it's amazing. I think it was $400 million in venture capital seed funding. It was a stupid amount of money for a Silicon Valley startup that was doing fresh pressed juice to people's houses. So they had a machine that would receive your deliveries of these juice satchels, and it would squeeze the juice satchels into cups for you. So you just think about that carefully. It's a machine that takes juice that is delivered to you in a bag, and it squeezes the bag. So it does this. It squeezes the bag so that the juice comes out of the bag and goes into the cup. And Sam's looked it up there. A boring juice product sold itself as the next great technology phenomenon. There's only one way things could go. Yeah, exactly. Who's that? I think a friend of mine might have written that particular article. I'm not sure. But I do have a friend who wrote an article on that, because I've got a friend who works as a tech journalist, and so that could even be her article, which is really cool. Anyway, that's why I heard of it originally. Yeah, let's not go too deep into that, but people figured out that you can squeeze the bag. So you just get deliveries of the stuff and squeeze the bag yourself, and not buy the $400 Internet of Things activated I don't know, demographic recording machine that would apparently do other stuff other than just squeeze the bag. Also, if the stuff was out of date, it would like scan the barcode and would refuse to squeeze the bag, and you'd just be like, oh my god, it's fruit in a bag, I'm just gonna squeeze it, buddy. But anyway, and as Michael's saying, you could buy juice like a normal person and just not spend the hundreds of dollars on the juice machine. Anyway, okay, so you're gonna have an idea, and you're going to have an idea, and chances are, if this is a thesis, you're going to already have put a whole lot of work into this. So you know what the idea is, you know what the main focus is. And if you know what the main focus is, you know why something exists, you know that if you are doing this as code for a program, you know you're never going to write any code that doesn't serve the purpose of the main idea. You're writing in your research paper is the same thing. You don't write code that doesn't help solve your problem. You don't write anything in your paper that doesn't help solve your problem. Again, you don't have to edit this as you're writing it, just throw all your ideas in later, but it's good to think about the focus. It's good to bring everything back to the focus, because what you're trying to do is you're trying to present this idea, and so all the different points you're making are going to be coming back to this one idea. So it's just about focus when you're creating something, and that's exactly the same when you're creating a document as it is when you're creating a program. So when I'm creating a program that is going to, I don't know, do some admin on student records or something like that. I don't really do that often. That's why I have admin staff in my subject to do that. But I do stuff like this instead. But if I was doing something like that, I'm not going to BOGO sort it. Just to throw back to what we were talking about earlier, because BOGO sort would be code that wouldn't help me with what I'm doing, so I wouldn't add it to what I'm doing. A lot of the time when we're writing, as humans, we can get caught up in writing filler. We can get caught up in writing stuff that doesn't focus on the point. Or we can write things that does help with the point, but we forget to relate it back to the point. So if we don't relate it back to the point, it loses context. So this is like writing a really useful function that's going to sort our student records or something like that. Or it's going to link our chains together, and then we forget to call that function. So because we haven't linked it to the context of the program itself, it doesn't make any sense. So we're gonna be thinking about that as well. Whenever we write something, we have to think about, how does this support the main point that we're making in the paper? The main point of the paper is something we never want to leave our minds. It's always got to be prevalent. And so when we put something together, it is linked back to the main point in some way. I'm going to give you specific techniques about that in a second. Arthur Wong saying, tweet was sent from my juicer. And Yusuf Khalid saying, yeah, a product that provides a solution to a non-existent problem. It is really sad when that happens, because it's obviously someone's had a cool idea, and maybe it solved a problem for them, but it didn't help anyone else in the world. So it was like, oh, that was actually really, really personal to you, and you're not really going to be able to sell that. I always get really sad when I think about Google Wave, because I think Google Wave was a tool that if it was released right now, it would be really handy, because we've now grown into this way of thinking and this way of developing, the way that we use, Trello, Slack, Git, and all this kind of stuff, and like all our stuff's on Google Docs so that we can edit on the cloud and collaboratively edit. A lot of Google Wave went into Google Docs anyway. When it first came out, a bunch of us tried to use it for projects and things, and I think it would have worked, but then it just sort of fizzled. And I think it was just because they were solving a problem that didn't exist yet. And they didn't know for certain that it was going to exist, and it does now, and it would solve the problem now. But I think it's too big for Google to go back to it now. They've moved on. And we've got other ways of dealing with it nowadays. So anyway, when we're writing, main problem, go back to that problem, make sure everything links back to that. So now we're going to start to talk about actual writing of stuff and the order that we're doing things. So at this point, so this is actually chronological. This is not just me saying, okay, I'm going to talk about this and this. We're thinking about this chronologically in what needs to be done when. We now have a literature review written. It may not be good. It may not even end up being on topic. It might be off to the side of the topic, and we don't know until we've written our other parts. So we're going to start to think about writing chapters. So when I said before there's one point that we're focusing on, it's never on its own, right? It's never the only thing that you're going to be talking about. Everything's going to tie into it. But as you have all these ideas for what you want to write about, you can put these, there's different ways to deal with this. You can put these in a document. in like a Google Doc or an online doc or something like that. Or you can get really physical with these things and write down all your ideas on little post-it notes and stick them up on a board or a wall somewhere. Um, as you do this, you will realize that some of them are really similar to each other. Some of them deserve to be clustered together in certain ways. So it's like if I'm talking about chaining blocks together, I'm just trying to figure out how to do this metaphor so that it works. Especially when I have no idea about blockchain. I'm not even sure many of the people watching at the moment have an idea about blockchain either. But who knows? Let's go for it anyway. So some things are about chaining blocks together. Some things are about figuring out if blocks are chained together. Other things are about like what the block structure is. And these things start to sort of coalesce into ideas. As they do so, you will start to realize what the chapters are. As I said before, it's pretty easy when we've worked on something where it's like there was the process that made us think that the program was going to work. This is before we wrote the program. This is all the whiteboard stuff that we do with our research to say, okay, we're going to aim in this direction, which means that the kind of software we want to write is probably going to want to solve a certain problem. So we think about the problem and we think about what kind of things solve the problem. So that can be our entire chapter saying, okay, these are the things we thought would solve the problem and the ways that we could approach it. And then the second thing is like, okay, this is the one that we picked. So we picked this one, here's some more detail about it. And those are separate because one of them is about the ideation process, the process of figuring out which idea we're going to use. The next thing is like, okay, now that we solidified one idea, how did we actually build that? So this is about building things. One's about thinking about things, the other's about building things. And then you have another chapter which is like, okay, we did all this testing and we got all these results. So here's the other chapter that says, okay, here was our testing. This is why we thought the testing that we did was going to give us useful results. This is how the testing relates back to the main point. The main point is like saying we want to solve X problem. So we can say all of our testing data comes from the problem set that links back to the problem, so everything ties back. The chapters will end up doing this. So as you work with it, the chapters will end up sort of not writing themselves, but you will know what topics should be in each chapter as you play around with the topics and figure this out. I'm being really vague here because it's very hard for me to decide for you what's going to be in your chapters. Yusuf is laughing at me because the blockchain example keeps backfiring. I should have just said, okay, the example I'm using in this talk is about developing a computer game, because then I will just, that's easy, I can just reel that stuff off. I know exactly how to do that one. So, but instead, someone got me onto blockchain, and now that I'm linked to the chain, I can't get unlinked. So I don't know what's happening. Anyway, yeah. Sam's laughing at me. This will be relatable. I don't even know if it's relatable. Anyway, let's continue. So, the way that we can think of this, like going back to the example of like the research paper is a program, is that each of the chapters is a different kind of functional component. So in your average program, you could think of each chapter being a separate file that we've built as a library, for example. So we build our own libraries to do specific tasks. Each chapter is a library that we've built for a specific task. Each one is going to be used as part of the whole. Each one kind of commits its work to the solving of the original problem, but each of them has completely separate functionality that works in a different way. So if we can think about our topic material as that, we'll be able to split it up into different parts. This is vague because there's no way I can tell exactly what you need to write for your chapters, but at least I can try to give you a process of how you separate things into chapters. Once we get into chapters, each chapter is going to be made up of paragraphs. So the paragraphs get us down to a lower level. So when we think about paragraphs, we think about each paragraph is making a single point. That's all it's making. So it's making this single point and it's trying to give this information to people. So one of the structures, and there are many, but this is one of the structures that will be taught in something like high school English when we're doing essays. So an essay is, I guess the way that I would define an essay is a argumentative, formal written document. And when I say argumentative, I mean it says it has a point that it's trying to make, and through correct and elegant use of words will try to convince someone that the point is correct. A research paper is not that much different, but it's not necessarily going to use the art form of words to try to prove that something's correct. It's going to chuck in a bunch of diagrams from experimental data and say, we think it's correct because we received this kind of empirical data, or we think it's correct because following from certain axioms of mathematics and through these proofs, this thing should end up like this. And I say should because we never know for certain. You can say Bogo sort should give us an answer, but whether it does or not, who knows? So this structure, and so this is where we're getting down into, like, this would be at the level of code style. Put your brackets here, put your semicolons here, indent your lines like this. This is at this level. And if you want to use this, you totally can. If you don't want to use this because, I don't know, you want to get in a fight over camel case versus snake case, you can do that if you want to. This is not the only way of doing this. This is one of the paragraph structuring techniques. You will find that someone who is, say, an English major or a writing major won't need to learn this. They won't need to learn this at all. In the same way that I don't need to teach any of you how to write a function or a method in your chosen programming language, because you know how to do that. But I would definitely need to teach an English major how to write a function. That would be very difficult for them. It would take some time. And the same way goes back in the other direction. If you need to write a paragraph but you have no training in what a paragraph even is, this can help you. So it's called TEAL, T-E-E-L, and you can do this if you want to. You can 100% get away with this if you want to. Every single paragraph that you write has exactly 4 sentences. The first one being the topic, saying, okay, this is what this paragraph is about. So this is saying, okay, this is what I'm going to say. Then explain what you meant by that. So you say, this is what this paragraph is about. And what I mean by that is that this links to this via this idea. This is shown in this way. So you present some evidence. So you say, this is shown by these theories, or this is shown by this experimental data that these things linked up. And this is why it makes sense to understand this minor point, because it links back to the main point in some way. And so you could totally get away with this if you want to. This is like one of those simplest forms. So this is like me saying to a beginner programmer, just follow the style guide. Don't think, just follow the style guide. This is me saying that same thing. So the first thing is like what I'm about to talk about. A bit more detail on it. Show something that proves that, and show why this is important to the main topic, and just do that every paragraph. And you'll find that each of your chapters is broken down into different points, different smaller points. Each of those smaller points can have a paragraph that looks like this. And if you want to later, you can go back and read it through and go, some of this doesn't make perfect sense. Some of these need 5 sentences because maybe the explanation took a bit longer than that. It was a bit long-winded to squeeze into 1 sentence. Some of them have a great deal of evidence, and so we don't want to just leave it as 1 sentence there. Some of them did not need an explanation because the explanation and the topic were one and the same, so they only have 3 sentences. You know, you can massage this. This isn't a set of rules. This is a set of guidelines. What are we saying? Blaze is getting English PTSD. And Sam's saying you can also think of the EE in the middle as a struct, and you can chain them together to make a linked list. Yeah, everyone's getting HSC flashbacks. I love it. I love it when people join a particular degree and they say, I'm glad I'll never have to do that thing again, and they get partway through and they go, oh, I probably should have listened more when I got into that. I used to teach people how to make computer games, and it was really funny when I told them, you need linear algebra. And they're like, what? It's like, you know all those matrices? Did you do like 4-unit maths on those matrices? You need them. Can't make computer games without them. And they're like, no! If someone had told us that before, we would have done work on it. And it's like, oh, well. And it's like trigonometry. It's like, you can't do a 3D environment without trigonometry. You can't even do a 2D environment without trigonometry. And it's like everything about angles. And like, so computer games are all based on angles. And it's, well, all based. I'm just like, that's all computer games are. But yeah, computer games are very much based on like, if you need something to move in a simulation of the real world, then it needs to know what angle it's aiming at and stuff, and it's all trig. So it was really funny teaching people that, and they were like, oh, I just want to go back to year 10 again, knowing that I'm really going to care about this later, and then put effort into it. And I'm feeling that's the same thing that's happening here. You're like, I've heard this before, and I tried to erase it from my mind maybe 2 or 3 years ago. Thank you, Nerdy Gamer Geek. If you think of each letter as a block, then you can think of each paragraph as a chain of blocks together. We're back on blockchain. Michael's saying that your game dev career is over before it began. You know you can relearn that stuff. You know, I think everyone knows this concept by now, right? Like, if in university you reach a certain point where you look back at the stuff you did earlier in university and it's really easy. So I could give, I don't know what stage everyone's at here, but I think there's a lot of 3rd and 4th year students here. And I could give you, as 3rd and 4th year students, I could give you the first assignment that I give introductory programming students. So people who have never done any programming before, I could give you that assignment. And I could start a stopwatch and I say, all right, 60 minutes. And I could probably get HD level assignments out of everyone in 60 minutes for these things. I give people 3 weeks to do this, and I expect you could probably do it in 60 minutes. Trigonometry is like that for you now. You're at a level of a university, at least partially university educated human being, where year 10 maths is going to be really simple. You could just look at the textbook now and go, oh yeah, I can figure that out. It's easy, you know? So I don't think it's that much of a problem. Though I have to go through that process every time I teach something that I'm not currently practicing. And honestly, at the moment, I'm currently practicing how to teach. So like all of these like advanced programming concepts and stuff like that are just sort of sitting in the back of my head, but they're languishing. So if I was going to teach something like I used to teach, like something really difficult, like building a physics engine or something like that, I'd be like, I'm going to need to go back and think about that, but it's going to be faster than someone who's never done it before. So I think you'd all be fine. Shrey. Relearn! No! I think I put Shrey into a panic there. And Sam Shrey is saying that the Minesweeper assignment in 60 minutes. Yeah, chances are you could do that. Who knows? And Arthur saying, starting software engineering, I'm sure I won't need complex numbers ever again. Think of it this way. Computing is not a field on its own. It's a very controversial thing to say because it is. But computing is just applied mathematics in a discrete binary form. So if we take a whole lot of the other stuff out of mathematics and we only do discrete binary mathematics and we do it in a very applied context, practical implied context, and build on the possibilities there, that's all that computing is. Yeah. Shrey's quoting me, picking out all the quotes in here that are the most damning of the things that I say. As I said before, just be free with your creation of things and then edit them later. As opposed to me, who I'm just being free with my creation of things and then I'm recording them and I'm putting on YouTube so that I don't actually get to edit them later and go, that was a dumb idea. That was flat out incorrect, what I said there and stuff. When you're writing a paper, you are going to go back and you're going to correct those things. Okay, so that's paragraph structure. If you need really simple rules, follow the simple rules. When you understand how to break those rules, you can break those rules as you need. This is the cornerstone of education in general. I would teach people the simplest way to do something, knowing that it is not 100% correct. But it is simple and it's easy to follow. So if you don't want to figure out how English language prose structures paragraphs and all the subtleties involved in how paragraphs change the attentiveness of a reader as they flow and things like that, if you don't want to know any of that stuff, you can just follow this instead. Because these rules are made from those same principles. But I think for a lot of people writing scientific research papers, it's not entirely relevant for you to need to know all of that stuff. If you want to be an author and you want to hold people's attention through 300 pages of something, then if you don't know this stuff, you're nothing, right? It's the same way as me saying, if you want to be a computer programmer, you want to write 10,000 lines of code, you want to be coding for, you know, 30 hours a week because that's the work that you want to do with your life, and you don't know all the ins and outs and subtleties of how a function works, then you have no business doing it. So that's the same kind of thing. But if you just want to write a research paper outlining the coding work that you've been doing, maybe you can just follow this simple thing instead, rather than trying to understand the full nuance of everything. And in the same way, it's like if I'm training someone to be a computer scientist, but their focus on computer science is not going to be on programming, their focus is going to be on algorithm design or something like that, then I don't care if their style is 100% correct all the time. I would care more about whether their analysis of algorithms is correct. So you put your effort and your nuance into different parts of what you're going to do. And so that's why I'm saying you can follow this if you want to. It's very simple. Okay. Then we write the conclusion. So after you've got your chapters written, and again, what I'm saying here is that your chapters are not necessarily written, they're an amalgamation of paragraphs. Each paragraph has points that support the chapter. The chapter can nearly have a teal structure itself in paragraphs instead of the teal structure in sentences. So it's like a hierarchical structure. You can use it at different levels. You could even say that the introduction is the T, the paragraphs are the E, and the L is the conclusion. So even if we go back to here, this is the T, these are the E's, and this is the L. You can follow the same structure at different levels of the hierarchy if you want to. Okay, the conclusion is where we bring everything back to the main point. So this is the thing that I was saying before. You tell people what you're going to write about. Then you write the thing, and then you tell people again what you wrote about. You don't assume at any point that people have gotten to the conclusion and they've picked up everything that you've written along the way. In the same way that when I am lecturing students, I don't at any point assume that they have memorized everything that I said in the lecture. That's like asking someone to watch a movie, even a movie they love, but they watch it once and then know all the words in it. That's impossible, right? We're not expecting anything like that. So what we need to do is we say to people, all right, now that I've given you all these words, I've given you these chapters, and the chapters can get really long, you know, because let's say I've got 3 chapters. Each chapter has 4 or 5 paragraphs in it. So this is actually a pretty small research paper if it's only that long. That's already like you've just dumped like 1,000 words on someone. So the chances of them remembering all of that are pretty small. They've now gotten caught up in the nitty-gritty of the chapters and all the different parts. They may have forgotten what you were talking about in the introduction. They may have been talking about, they may have forgotten about what the field is and exactly what your contribution to the field is. So the conclusion is your chance to wrap this whole thing up and say, remember the main point? This was what the main point was. And let's have a look at how everything that we've done so far supported that main point. So a good conclusion says, this is what we think we've gotten out of this. This is what either we learnt from doing this work. This is what our evidence suggests. So it's us saying that we chained sets of 3 blocks together, and in chaining sets of 3 blocks together, we significantly reduced the search time necessary to traverse an entire chain of blocks, because we're allowed to traverse different paths through the chain. In doing so, we increased a certain level of redundancy, but what we did was, but also on top of that, we made a search through the blockchain much more efficient than it was before. I am totally making this, I have no idea how this, but you know, yeah. So we can say this is what we got from all of this research, and this is how it links back to the main point. And we finish our argument. in a sense. So if we were saying at the beginning, we want to find a way to make chaining blocks together more efficient. And then we found a way, we developed a technique that is still just as secure, but it chains 3 blocks together at a time instead of 2 blocks together at a time. And we've proven in testing in real world usage situations that these things are currently in, that this thing always returns its answer faster than the standard chaining method. And we're like, bingo, we have answered the question that we asked at the beginning. And then we can say, okay, let's talk about where this could go. So this doesn't always have to be there, but it's kind of useful to have. It's always nice to see like someone's thinking about what the context of their research is and where could this go. So I could say, all right, now that we've shown that the tri-chaining blockchain is more efficient in these circumstances. The next work we could do is to try it in different situations. So we tried it in this specific set of test situations, which showed that under certain circumstances it's quicker. What about these other circumstances? We haven't done this testing, could be worth doing. The other thing that we were thinking of is the quad chain. What if we quad chained? What happens then? I think the world explodes, the time-space continuum collapses. But, you can talk about that kind of thing. So, Michael's saying that he wonders if there is anyone doing their thesis on blockchain who is watching this and beginning to question their life. What if tri-chain is like actually useful? I think that would be one of the best things, is me saying tri-chain blockchain is actually a thing, and someone's going to be like, we're actually in the middle of that research, and the results are similar to what you're saying. I think that would be really funny. So we can talk about where this could go. So your conclusion is your way of saying, okay, let's wrap up everything that we've done, and let's make sure that everything that we said before ties back in. So if you find that you're summarizing things here, so you're saying how the chapter supported the main point, and one of the chapters just kind of gets left out, then you want to go back to look at that chapter again. So you want to go back and say, okay, if I write this conclusion and one of the chapters never gets mentioned, because for me it makes no sense because it doesn't support the main point, then you go, okay, why is that chapter here? It still could have a good reason for existing. So this chapter could be, here is the chapter of all the things that don't work in this situation. So we did do our research. We researched into tri-blocking, not tri-chaining. So it wasn't chaining 3 blocks together. It was combining 3 blocks into one. I don't even know what I'm talking about. Yeah. And we found that didn't work because it makes no sense. Probably makes no sense. I should stop talking about blockchain. One day I think I'm gonna have to do this now. I'm gonna have to go and read about blockchain and actually try to get an understanding about it. Yeah, and so we tried this and it didn't work. Or we can say, look, we actually did try the quad chain, but the quad chain was just bogged down in infrastructure to the point where it wasn't more efficient. So this is why the tri-chain ended up being the implementation that we worked on. Having said that, that still could make it into your summary. So there could be reasons for chapters to exist that aren't necessarily in the conclusion, but nearly all the time I would expect that all of your chapters will be referenced in some way in the conclusion, where we'll say, okay, in this chapter we show this, in this chapter we show this. All of these things tie back to our main point. Because you probably shouldn't have been writing any of these chapters if they didn't support the main point in some way. So everything you judge against your, if I can use an engineering term, you judge against your requirements and your initial specification. If something doesn't support your requirements, then it doesn't really have a place in what you're doing. Okay, so paper is titled "The Tri-Chain of Power." It's pretty funny. I'm glad, at least, even if I have completely failed in my task and I'm not even educating anyone in how to write a technical document, I've entertained you in showing you how little I know about one of the kind of biggest developments in computer science that's happened in the last 10 years. I should point out that it is entirely unnecessary for a computer scientist to know everything that is happening in computer science. So I know a lot about very specific things, but I know basically nothing about other things, and that's acceptable because there's no way that one human can be a master of all possible things in computing. Okay, so that's what we're doing with that conclusion. We're trying to complete everything and saying when we when we kind of tie together the conclusion, what we're saying is at the end, this is what I was trying to tell you. So at the beginning, you say, look, I want to tell you about something. And then you tell them about it all through the chapters. And in the conclusion, you say, look, let me say this is what I was trying to tell you the whole time. And, Blaze. Only the avatar can master all things in computing. Yeah, so I'm obviously not the avatar, so I can't master all elements. I'm trying to think about what I am. I think I'm a game bender. Because everything that I've done that I've actually had any mastery over has always been applicable to making of computer games. So AI that plays games, graphics, human-computer interaction, and stuff like that. The programming has only ever been to support doing those other things for me. Okay, what was I going to do? So let's go back to this thing. We looked at a bit of background. We've now looked at chapters and conclusions. So we've actually done the chunk in the middle, but we haven't. I'm actually not even going to talk about references. I said that in passing. You do need to do these. A lot of these are going to be in your background. But I think that either I should add something to this that talks about references at some point in the future, but I usually think of references more as a mechanical task that you do that doesn't require you to actually think about what you're writing. Excuse me, talking too much. Doesn't necessarily require your imagination or writing skill to do. You just need to put them in the right places. Interesting that I have not done my introduction or abstract yet. So after the conclusion, then we write the introduction. So the point of the introduction is to prepare someone to read the paper. If you want to prepare someone to use something, it is very, very hard to prepare someone to use something that doesn't exist, which is why we write pretty much the whole paper before we write the introduction. So for example, I can't say, here, let me take you for a tour of my apartment if my apartment doesn't exist yet. I mean, sure, there's VR technology for architecture and stuff like that, but we're not even going to think about that for the moment. If the thing doesn't exist, you can't introduce someone to it, which is why you don't write your introduction until after the paper is written. So this is why the introduction comes this late in the process. So we won't write the introduction until we're sure about what it is we've actually said. Because as we write the conclusion, we may find that our main point has changed slightly, because we may find that there are some things that we wrote in our chapters that were more important about the main point than other things, and so we'll use them instead. And so that might change the main point, which will change the way we introduce it at the beginning. So what we're going to do when we write an introduction is we're going to give people the tools they need to read the paper. So first thing that people need, definitely, to be able to read the paper is to know what field it is in. So we need to say, this paper is about blockchain, and it's about increasing the efficiency of traversing a blockchain by modifying the architecture of how blocks are chained together. It's not a bad line, by the way. I'm pretty happy with that. In order to understand that, we have to look at what blockchain is, and so we need to say, all right, blockchain is this. And then you will cite the paper that you need there. And this is like the background section where you've got all these papers that you needed to read to get to where you're up to. Chances are someone else is going to need that. The way to decide what level to write your background is to assume that someone else has a university level education, but they do not have a PhD in the particular field. Easy to do because you also don't have a PhD in the particular field. But if you do an honors thesis in the particular field, then you're ahead of someone in that field in particular. So someone else is going to have completed, say, undergraduate education. It's going to be reasonably similar to where you are if you're writing a thesis. Because if you're writing a thesis, you could actually, like, if you want to exit your degree with just a bachelor's without honors. So technically, you are a completely university educated individual. Um, Different for engineering degrees, but even engineering degrees have the option most of the time to transfer to a science degree in the same field and not do a thesis. There's, I don't know. I don't know all of the nitty gritty of how it works. I did my engineering degree all the way through and did a thesis as well. Um, so the background, deciding what goes in and out of the background. I mean, I could have talked about this a bit more in the background section, but deciding what goes in is saying what do you need on top of a basic computing education, I guess, to be able to understand what we're going to talk about. So you need to show the overall field that you're in, show the current state of work in that field in a more narrow way, the closer things to what you're doing. And then if you have those kind of crucial few papers that you're extending, those ones are good to talk about. So you can say, okay, these people worked on this thing. They got this far, they did this. These people worked on this thing, they got this far, they did this. These kinds of results are the things that we accept are the current state of the art right now. And then we can talk about what we're going to do, which is what you then do is you set up the main point. It's really easy to set up the main point if you've done your background well, because your background leads to it. So your background is like, here's the whole field, narrower, here's a part of that field, narrower, here's some of the papers that have shown what is done in that field up until this present day. So these will be very recent. These will be less than 5 years old, some of these. Unless you're going back to research that people haven't been working on recently. That's very rare in computing because computing is a highly active research field. Where nearly anything that you're going to be doing research on, it's very unlikely that no one's touched it in the last 5 years. It's highly likely that someone else has been working on it, right? So you get your recent papers and you go, all right, this person last year published this work that they did on this, and this is the thing that I'm continuing. Chances are, if you're following a project that's currently in existence from a CSE academic, from one of us in the faculty, you will have papers from just last year, which is like, okay, this is the last thesis student who worked on this and they got to this point. You might want to continue directly from them, and so you'll have those papers. And so when you narrow that focus in your background section, you get up to the main point really easily, because it's like, okay, so as we can see from all this stuff, this is where it is, and then now this is where I continue from here. So that's where you set up your main point, and so you say, this is what we're going to do. And so this is what you say here in the intro, is you make sure that the reader knows where you're going to go. So if you don't establish the context and say, this is what we're going to prove here, it makes it really hard for them to read things, because if you don't say what you're trying to prove until the conclusion, then all of the chapters don't make any sense. But if you say, this is the thing that we're going to show, then every chapter says, you know how we were telling you before that we were going to show this? This is just part of how we're showing you this. And then keeping that context in mind keeps people's attention on the main point. And it means that everything then is also just compared against that main point, and it makes sense and you understand it. So no one gets partway through reading your paper with the misconception that you're trying to unlink the blocks in the chain. You're actually trying to add extra links to the blocks in the chain. To go back to the example that I'm using, that I still have no idea what it is or how it works, right? So make sure the reader really knows what you're going to do. And then what you can do is you can say, give them some idea about how you're going to present it. So you could say, what we're presenting in this paper is the work that we did. So we're going to talk you through the methodology of our research. We're going to talk you through the experiments we undertook, and then we're going to talk you through the results of those experiments. And by the end of that, you should have the same understanding that we have of what we were and weren't successful in showing. I say we because a lot of the time I work in research teams. If it's an honest thesis, it's probably going to be written in first person, because you should see the whole thing yourself. You know. I love how we're going into like Avatar: The Last Airbender quotes linked to blockchain. It's like we're just telling a whole narrative. Like, I do enjoy this actually. Sometimes we do narrative instead of actually learning, and then we find out that we learn so much from narrative. It's interesting, isn't it? What else have we got? I've got stuff in my notes here about. Oh no, I've talked about this already. Talk about what you're going to talk about it, and then talk about what you've just talked about. So the intro is the first bit of that. Talk about what you're going to talk about. It's good to know what you're about to talk about before you write the intro. So again, reason why it's here in this order. Once we've got that, we have the majority of what we need, but we haven't done the abstract yet. As I said before, the abstract is a TLDR. TLDR stands for too long didn't read. So we talked about what it was used for at the beginning, that someone might read the abstract as a decision-making process of whether or not they need to read the rest of this paper. So if someone's too busy to read the details of things, but they're happy that you generated a result that that they can use, then say I'm an executive and I have staff working for me, I can look at a bunch of research papers and I can look at one of them and go, this appears to be solving one of the problems that we have in our current work that we're doing. This extra chaining of blocks might be really interesting. So I hand that off to one of my technical staff and I say, I think that this might be useful. Just see what you can get out of it. And then the technical staff has to actually go through and go, all right, how did they implement this? And did they do a rigorous enough proof of how this works that we could use it? Can we re-implement this in our system? And then we'd have that discussion. But as an executive, I would just look at. I'm just promoting myself, by the way, just for the fun of it. Usually, I would be like, well, the executive would hand it to me. Then I have to decipher the research paper and decide whether we can use it or not. But I've just recently given myself a promotion just for fun. So what we want this thing to be is pretty quick and fully understandable in terms of the entire paper. So there are no references in an abstract. Even though you may mention things in the abstract that need references to be understood, I think you're not usually going to have references in abstract. Anyone who's been reading, see you later, Shrey. Anyone who's been reading research papers will be able to tell me whether there's references in an abstract, but I'm pretty sure there aren't usually. You can sometimes boil an abstract down into 3 sentences. You can sometimes literally be only 3 sentences, and that would be these 3 things. What is the paper about? Why is this being done? So this is like saying, this paper is about chaining sets of 3 blocks together in a blockchain instead of the usual one-to-one connection. Why is this study being done? This study is the study of this multi-chaining method has been done so that we could try to increase the efficiency in the speed of traversing the entire blockchain or something like that. We have built this thing and we have tested it using data from real world situations or whatever it is. Like, I'm obviously not writing the paper now because it doesn't exist, but I'm just trying to use this hideous example of tri-chain chain blocking that we've been talking about. So this is what we did. We came up with this theory that mathematically it should take less steps to traverse this chain. We built this infrastructure. We built our own setup using this, and then we tested it using this data. The thing that we found from doing this was it was more efficient under these types of circumstances, but required more overhead in these particular ways. That is my abstract. So what I've done there is I've said, this is what we set out to achieve. This is how we tried to do it. This is kind of nearly like what's in our chapters, and this is a one-liner to tie it up. Like, this is what we actually did. So the introduction never says anything about whether you succeeded in your point or what you proved or anything. The introduction is there to just say, this is what you need to know to be able to read the rest of the paper. Whereas the abstract is something that says, if you read this and you don't read the rest of the paper, you are going to get a correct overview of the entire paper. So the subtle differences you start to see between these two things The abstract is something you can read if you don't want to read everything else. The introduction is what you read if you do want to read everything else. So it's specifically teaching you what you need to be able to read the rest of it. So the introduction doesn't need to give you all the answers that are at the end, whereas the abstract is going to want to give you a summary of the answers. That's interesting. What is the paper about? Why is the paper about? Yeah, very much so. So that's the kind of thing that we're gonna say in the abstract. And then at the end of that, like the third one is like, what did we learn eventually? So, having written that, we've written all the components of our paper. Oh, we hit 4 p.m. I told you I wasn't going to finish at 4 p.m. So we're finished, right? At this point, we have written the entire paper. We're finished. Yay! No, 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 no. Okay. So, I always laugh at this particular part of this. Do we release code if we've finished writing all of the components that we need and it compiles? Do we just release that code? And I always ask this, and someone says yes. I'm just like, no. So I'm not going to judge, because I know that it happens, and I know that it happens sometimes that you just release the code the second that it starts working. You're just like, I don't know what's going to go happen. It's all just over. Like, we don't have enough time left to make this work. We just got to release it. But in a perfect world, where we do things the way that we think is proper, we do not release code when the first time it compiles. We then, yeah. And Arthur's there, we're going to test in production, right? So we need to test things. And not even, at this point with our paper here, we haven't even done internal testing. As Sam's saying, compilers detect logic errors, right? Because there's actually very little syntax testing in a paper like this that's going to help you. Yeah, we can look at grammar, we can look at spelling errors and stuff like that, but even with spelling errors, our meaning could get through. So what we're looking at then is, how do we do a proper testing pass on a written document? And so that is proofreading. And so what I wanted to talk about is to relate proofreading back to software testing. So we could say the following. We could say, I'm an expert at testing code, because by the time you write a thesis, you're probably an expert at testing code, because even your thesis code is a massive project that, like, I can't remember how big my thesis was. It was a very long time ago. But I think it was like, I did it. Also, this'll date me for the time period where it was a reasonable thing for me to do to complete my thesis in C++. So I think that puts me at a certain era where C++ was considered a frontline industrial programming language, and that's one of the reasons why I used it. I think I had something like 3,000 lines of code, potentially. Could even have been more than that, but I can't quite remember. But where was I going with this? The use of saying it still is. I think it, yeah, I mean, definitely, depending on your industry, it still is. I think in terms of, like, in consulting, business consulting and stuff like that, that level of business, you're going to see a lot more Java. In the big tech industries and like AI and things like that, machine learning and deep learning, people are using Python a lot more. But I know that in games and stuff, we're definitely still using C++, because we have enough control over the computer with that to use things. Okay, so let's look at testing. I can't remember why I was talking about my thesis and how big it was, but anyway. So we're going to do testing at different scales. So there's a big picture. Does the message entirely get through or not? Is the main point coming through in everything? Then, when we test individual paragraphs, this is a bit like unit testing. So when we're unit testing individual components, like individual functions, we will just throw inputs at them, read their outputs, and see if those things are coming out the way that we want. This is like saying, is it following teal? Um, if not, is it still making a point? You know, is it still saying what it needs to say? Um, then we can look at individual sentences, and we want to think about the test of whether an individual sentence works or not is whether it makes sense to a human. You can use this on yourself, or you can use it on other people. One of the things that I do that that helps a lot, and obviously as a lecturer, this is like quite an instinctive thing to do, is I read it out loud. So if I read a sentence out loud and it comes out of my mouth weird, and I hear it coming out of my mouth weird, then I think, what's causing that? Is it ambiguous? Is there something that just doesn't flow in terms of the words? Is it causing people to have to read a word, then skip back to read another word to understand it? You know, we can shift things around without changing the core meaning of it, but just to get it to flow better. Um, I sometimes think that it's good to, if you're writing a big technical paper, is to have read every part of it out loud at some point before you submit it. When we get down to the nitty gritty, we've got syntax errors. These are really simple. Spell checkers exist for a reason. You can even throw your paper into a grammar checker. I would sometimes trust them. Sometimes they ask you to do weird things, but at least they can tell you when you're in outright violation of the rules of English, and you probably want to be careful if you're in outright violation. The only problem with throwing a technical paper into a grammar checker is that they will pick up a lot of things that are scientifically correct from our understanding, but they're not grammatically correct, and you have to say, look, we're going to leave that in. But at least you've got something to look at it. And also, getting someone else to read it. This is old school. Super old school thing is you don't even look at it yourself. You just pass it to someone else and ask them if they can understand it. It's probably not bad to get to know other thesis students, because you can pass things around. Oh, another thing. Everyone's going to have an assessor and a supervisor. I don't know why I forgot that word. Assessor and supervisor. So you can bounce back and forth between them and get them to read it and stuff before you submit it. I mean, they're going to be the ones giving you marks on it anyway, so it's like the best people to get feedback on it. Another thing that you can do is you can get someone who knows nothing about the field to read it, and then you can figure out how far you've gone in terms of becoming a true scientist. The more true scientist you are, the less normal people can understand you. That's not a good way to be. I mean, it's the truth. It definitely happens. The more time we spend deep in research, the more likely we are to create something that someone else won't understand. It's just the way of it. But it is always good to get your nice research paper and get someone who's, probably someone with a university degree, but in something else, to read it and see what they think. You're going to have to take all of their advice with a pinch of salt, because you're not necessarily going to ask them to read all the background material as well. If you had a university educated person and you gave them enough time to read all the background material, then your paper, then you could get some really, really good feedback out of that, but that's going to take weeks and weeks. But at least you can get someone to skim over it who doesn't know the content, and they'll be like, I don't understand what this point is here. And you'll find that there's like a logical fallacy in what you've written that doesn't link up with the main point properly and stuff. And you go, okay, cool. You can get some structural advice out of that nonetheless. I should remind everyone, I wonder if yes, I was like, did I write a whole slide on this? I said, yes, I did. Software development timing, right? We know this. We spend a certain very small amount of time creating new content, and we spend a great amount of time fixing that. We do want to think about that when we're writing documents as well, is that reading and rewriting of your first draft should be more time than the time it took you to just put the words on the page. And again, this is me going back to that original point. Dump the words on the page quick. It's not important how good they are the first time you write them. In exactly the same way as a piece of software, is not going to fulfill the requirements perfectly the first time you write it. It's going to only be partially correct and stuff, but you're going to iterate on it to make it better. We can take that iterative approach and we can apply that to writing. In fact, it is even much better on this semi-creative process than it is in the software process. We think it's amazing in the software process to write stuff that's not that great and keep iterating on it until it gets better. When you're talking about interacting with humans, it's even more effective an approach than it is with software. So yeah, get that first draft out fast. Just spit it out there. It's better the less you pick at it, because then it's honest. It's honest and pure and direct, and you'll get some ideas out of that are going to allow you to keep some of the nuance in what you are thinking as you refine what you're doing. So, iterative process, and this is like I don't think I need to tell anyone this, because I could take the word writing out of this and I could put any other task that you want to do in here that you want to have a good outcome at the end of your process. Is that multiple tries at something that don't try to be good, but they just try to be a little better than previously, is always better than only doing something once and trying to make it perfect the first time. You're more likely to cripple yourself in that process. So, I mean, like, there's just so many buzzword slogans everywhere, in not just development, just in management of humans and stuff like that, saying this same thing. Finished is better than good. And things like fail faster. Again, that's about an iterative approach, about just getting stuff happening so that it can fail and then continuing. All those kinds of things people are going to tell you. They come from many different fields, and that's where you know that something has an element of sort of deep truth to it, that this concept, I learnt this concept again from painting. When I was painting, I learned that this is that people like, just finish more paintings, don't try to make one good one. And in artistic pursuits, it's very much like that. Software knows this as well, and so if you get this coming from multiple different places, you understand that this is very, very much fundamental to human beings. So definitely use it to your advantage whenever you can. Yusuf was saying game engine development for C++. Yeah, definitely. Yeah. That's why I still know it. Sam doesn't like Python. It's alright. I mean, I never try to like or dislike programming languages, because I know that, like, depending on where I go, I'm just going to have to use the language that's there. So I try to be all like, I'm a computer scientist, which means I will learn any language I need to speak to the computer. Sorry, just going back through chat. Nerdy Game Geek. Is it good or bad if normies can read your paper? Let's not call them normies to start with. When we are creating science, we are creating science for the betterment of humanity. Even if it's nothing else than extending our knowledge of things, and we expect someone else to then use it later to make human lives better. Whether or not people can understand it depends on how far out on the sharp end of the stick you are. So it's okay if someone who is uneducated in your field can't fully understand it. But there's a difference between understanding the difficult scientific concepts and you having accidentally written paragraphs that make no sense. So, when you're taking it to someone who is not an expert and you're asking them to read it, you're asking to see if they can pick up the flow of the writing on the page and stuff like that. Because you don't want to make mistakes with that stuff. Because if you make a mistake with how the stuff flows from point to point, then no one will understand it, regardless of even if they understand the source material. So sometimes it's you can uncover that with people who don't know anything about it, and sometimes people who are already experts in the field that you're in, when they read your writing that doesn't make any sense, they will gloss over it because they know the subject area. They'll be like, "Oh, I think I understand that." And then you might end up with a situation where you are logically not on the same page just because of the way you wrote, even if your understanding was good or not. So that's one thing to think about. Um, so as the discussion, Arthur is continuing the discussion there, so it could be good if, I'm not going to use the word normies, if people who aren't computer scientists, who may be a lot smarter than you, so don't call them normies. Yeah, it could be good if someone is someone who doesn't know your field can read it. In the same, I think Arthur's getting to the same point that I was, that they know if it's well written or not. They know if the communication style is getting through to people or not. And if it is entirely accessible, then it may not present your research fully. Because in general, if you're making something that no one in the world has ever made before, that's the definition of research. You're making something that no one has ever done before, because the whole point of research is to expand human knowledge. Generally, and was it Isaac Newton or Charles Darwin said that they weren't really doing anything themselves. They were just standing on the shoulders of giants, and they gave them a perspective to see a little further. I think it was Isaac Newton. Could have been either of them. It's a pretty common concept. I think we've all said it at some point. None of us is doing anything based entirely on us coming up with principles from scratch. So unless someone else also has all of that knowledge, they're not really going to understand where you're going with it. So you kind of need, that's why the background section exists. It's like, actually, we are standing on the shoulders of these thousands and thousands of people that came before us and built all of this stuff. So if someone who hasn't also read all of those papers leading up to that point can fully understand it, it might mean that you're leaving out some crucial details and nuance about what's going on. So, yeah, what Arthur's saying, it's a good answer, Arthur. It's nice. Okay. This is the bit where I'm already over time on when I was planning on finish this. And so what really happens? So, yes, I wasn't born yesterday, and I know that you're going to finish this thing at 4 a.m. the night before it's due. And the reason you're finishing at 4 a.m. the night before it's due is because you started it at around midnight when you finished procrastinating and decided that you needed to write it. So I think that this is the point where I just really want to say, when I'm saying please do as I say but not as I do, it still sort of makes sense that even when I'm doing this last minute stuff, don't forget the structure, the process, and don't forget the algorithm for writing. So this is something that happens to everyone, and it happens to companies and stuff like that, is the closer they get to a deadline, the more they abandon reason. And it doesn't make any sense, because no matter what you do, if you spend 1 week writing your thesis after a whole year of doing all this research, you probably want to spend a bit more than that. Even if you're only going to do that, follow the algorithm. Because even if you have to compress this thing into a really short amount of time, it still works better to do these things in the right order than otherwise. Because if you just go, I'm just going to write this in one pass, start to finish, you're going to write your introduction and just flat out going to be wrong. Because then you're going to write your chapters, and as you write them, you're going to remember the things that make sense for these chapters, and then suddenly the whole flow of it is not going to be what you said the flow was going to be in the introduction. So you'd have to go back and rewrite it. And then you've just wasted time, even though you thought you were going to try to do things quickly. No one ever is doing anything inefficiently on purpose. You know? Like, every process that we think about in order to do things is to get the most correct answer in the most efficient way possible. Which is what this whole process is to try to get you the best answer the quickest way possible. So if you follow these steps one at a time, I can probably make these slides available to you as well if you really want to. So what I'm saying is, even if it's last minute, even if you're rushed and stuff, don't jump to randomness in your writing. Follow the techniques that are proven, and then you'll get a good response out of this. You'll be able to create something that actually still makes sense. Yeah. I think that's everything that I wanted to talk about today. So I've gone a bit over time, but I think I'd sort of planned us all for the fact that I was going to do that. So, damn it, I should have written another slide. So what I want to say to wrap this whole thing up is, if we're talking from the concept of computer scientists, we're not necessarily trained in writing itself. So we don't have a very deep understanding of what it means to uh, present something to humans in English language in a form that they will instantly understand. That's not a skill that we've learnt. We have learnt how to present things to computers in a language that they will instantly understand, and we've gotten pretty good at that by this point. But whether we've gotten good at presenting to humans or not is not necessarily part of our training. We may have gotten good at it by accident. We may have gotten good at it by doing electives in other fields, which I think is actually quite an important thing to do. If you can't communicate with humans, you may not actually end up being that effective a computer scientist. I mean, sure, there's things that you'll be able to do, but I think it's good to think about learning to communicate with humans as well. Because your programs are going to have to communicate with humans, so if you don't understand, then they won't either. Until we get them to think for themselves. We're on our way. So what we do if we don't have the depth of training as someone who has been learning to write English their entire degree, where we've been learning to write different languages, how do we follow a process that sits with what we've learnt, leverages as much of the training as we have as we can in order to do this? And that's how I built this process. So what we're getting is we know what the framework is, and so we're going to fill out a framework. We learn how to read by reading research papers using an algorithm, and that algorithm is not going to be a brute force linear search. It's going to be a search that pings between the important points of things and is intelligent enough to jump between different parts of memory like RAM rather than directly. When we go to write things, we put together a workflow, which is that we are going to do certain things before other things, and we're going to take an iterative approach to our creation of content. And so when I say all of these things, I could be talking about writing a research paper, but I could also just be talking about a complete engineering project. And so I think that if you can view the research paper as an engineering project as such, it can be a lot easier to get these kinds of things done. And then if you want to, when we get down into the nitty-gritty of things, we can just follow a style guide, you know? So if we want to, we can just be like, okay, this is not going to tell me what content to write, but it's at least going to tell me the style of what I'm doing. I could, if I wanted to, make every paragraph exactly 4 sentences. I could make them exactly these things. I could use this style hierarchically in the paragraphs in the chapter. I could say every chapter is exactly 4 paragraphs. It's not always a good thing, by the way. You'll figure it out. You'll figure out where you want to extend on these things. And then you can see the order that I'm saying to do these things in is you figure out what your background is, then you figure out what your points are, you write your chapters. After your chapters, you conclude your chapters by tying all of them together into your conclusion. Once you've gotten that, you've got the body of the paper, which leads you to the introduction to teach people how to read the rest of the paper. And having completed the paper, you can write the abstract, which is just a summary of the entire paper in a way that someone, if they really, really need to, they don't have to read the rest of the paper to get your entire point. And then the iterative part, figuring out how to test. And we know as computer scientists that the difference between creation of code and debugging code is massive. 2 completely different skills. They both require a good knowledge of how a computer works and a good knowledge of how a programming language works, but they come at it from very different approaches. So you need to not just learn how to write, but you need to learn how to proofread. Whether it's proofreading your own documents or getting people to help you with proofreading, you can do a code review on a written document. So if you've been keeping up with your skills and you've got a group of people you're studying with and you regularly code review each other's code to see how things are going, you can do this with your theses as well. It's probably good to see what kind of social links there are between yourselves and other people who are writing theses. A lot of the people who are doing their thesis at the moment you already know because you've been in classes with them your entire degree, or you're friends with them. I don't know. Not everyone has their friends network linked up exactly with their study network, but still you may be able to find via the study network. You find other people and you read each other's papers. I should point out at this point the funny thing about reading each other's papers. My undergrad thesis was my assessor's undergrad thesis. So I borrowed his undergrad thesis and then just deleted all the content without deleting the headings, and that gave me the framework for where I was going to fill things out. So you can do that if you need to, and that's a similar thing to following a style guide, because I knew that his had already passed through the the challenge of having to have this completed, and so I said, all right, I'm going to use yours and see how we go. Obviously, by the end of it, it looked nothing like it, because I had put all my own content in. Some of the chapters, the number of chapters wasn't the same. Some parts had been completely removed and replaced by other things. That's fine. But at least it gave me an idea of the fact that there was an abstract, an introduction, a conclusion, a reference section. There were chapters on methodology, chapters on theory, chapters on experimentation and output and stuff like that. So there was something that I could follow. So I hope that maybe this framework that I've got here and stuff gives you a chance to kind of like follow that instead of necessarily having to make it all up from scratch. The first research paper I ever wrote, well, actually it was easy, the first one I ever wrote, because I didn't write most of it. It was in someone else's framework, so I got an idea of how that works. But I think the second one I wrote was a copy of someone else's framework, again, who I just filled out bits and pieces. And yes, it doesn't matter how much time you have to do these things, the process is still going to work. So even if you're fully last minute, don't lose your head. Keep focused on getting the best thing that you can get out of the time that you have, regardless of how little time that is or how overdue you are. There's heaps of people's theses end up a little bit overdue because at the very end there's a few things that you want to do, and a lot of the time your supervisors are going to, I mean, I think you still get marks penalties and stuff like that, but they're not going to throw you out of the uni for you not finishing on time, so there's still going to be this kind of final effort that you're going to have to put a lot of time into. Or for example, you could spend no time on your thesis for the entire year and then do all the code for your thesis in 5 weeks and spend 1 week writing. Not that I'm thinking about anything that happened in particular. But maybe that could happen. And if so, you still need to be really careful about your processes and do them correctly. So the trick is just never panic. And one of the best ways to never go into a panic is to always know what you're going to do next, because there's a process, which is this entire thing. I don't know if people want the slides. If you've got the kind of handout that I was giving out here, it kind of has everything that's in the slides anyway. So that's everything that I wanted to talk about. Are there any questions? I know a lot of people have been commenting stuff and talking about things in the chat already, but if anyone has any questions you want any more advice on or anything like that, feel free to hit up chat. I'm just pointing there because that's where my other monitor is that has a chat on it. Feel free to ping in chat now and ask any questions before we wrap up. Wondering. Oh wait, there they are. I was just checking if these questions were actually coming in or not. I was like, that would be really funny if my stream had frozen like 15 minutes ago or something. Arthur's saying, would it be a good idea to write parts of your thesis as you research? I think it would be. You don't have to write it. What I would say is don't write it like it's a formal document as you research, but when you're figuring out all the papers that you're reading to get the knowledge you need to go, I always write notes about each paper. So I will have a paragraph summary of each paper, which reminds me of why that paper exists. and why it's useful to me. When I'm writing my background section, I will nearly copy paste those notes in and then clean them up later. When I am deciding how I'm going to run my experiments, so these experiments are going to be done on this particular data set for this reason, I write down those reasons because that stuff's going to go into the paper later. When we give data to our program to analyze, I'm just guessing because I don't know what your particular thing is, but I know mine was like that. It was like I was writing AI algorithms to play games, so I needed a set of games that it could play that had different characteristics to show that this was capable of dealing with different types of situations. So that was the thing. It was like, okay, why did I choose these games? And I chose them when I was starting my testing, which was months before I was writing anything. So I needed to write down why I chose these things, and that stuff ends up going in. So what I would often do is I would have like a big live document, and I would have like headings for the different things I was doing. And then when I go to actually write stuff, I grab stuff from those headings. And I don't exactly, but I pretty much dump them into the paper, and then I clean them up and I say, okay, this is all my data that I've collected, and this is how I'm going to write about it. So I think your idea of like, yeah, writing parts of your thesis as your research is a good one. Donna's saying, for those of us who aren't in the middle of a thesis, is there a way to level up, accumulate reps for technical writing? I think that, I mean, if we were setting a lot of assignments for you over the course of your degree that ask you to write these things, then maybe. But otherwise, there's not much. You can start reading research papers, so you can start thinking about, okay, here's this interesting thing that I want to know about. Let's see if there's anyone who has done particular research on this. That can be a bit of a deep end thing, but having read some papers before you hit your thesis is nice, because then at least, hang on, at least you've got this bit, how to read, because it's very, very difficult. And I found this definitely because I wasn't prepared when I went into my thesis, my first thesis. I had like half an undergrad thesis that I quit, and then I restarted and did another one. The first one didn't go that well because I didn't understand what I was doing. I didn't understand what a thesis even was. I didn't understand what research was either. So, and I think that's fine. I think a lot of people are going to be like that. That's why it's your first research, an honors thesis. But yeah, so learning how to read the research papers is good. And also, if you have an idea about what you might want to do later, reading up about that field with these things is good. And then you can even start to, if you wanted to, you could write a practice paper. I don't know who's got time to do this kind of thing, but write a practice paper which is like, okay, here's my idea of what the field is. I'm not necessarily going to talk about what I can do in this field yet, because I want more experience before I can do that, but I could say, here's this, this, and this, and these are the things that I think make this field worthy of research. This is where the world's up to at this point, and separate each chapter into like different ideas that people have explored within this field. So I could say, I want to look at cloud computing data analytics for blockchain systems. And so I look at all of those fields and I'd separate these into chapters like, okay, so data analytics has done this, but how does it combine in these other things? And the other chapters like, okay, blockchain is this. How does it combine into these other things? That was me, by the way, chaining all the buzzwords together. And so all of those, yeah, I could write a little thing on that and just practice writing the sentence structure and things like that. That might help. Blaze, send help. I've barely done anything for Thesis B. Thesis B is the implementation stage, isn't it? Where you should be either testing whether stuff works or writing code that fits the theories that you've put together in Thesis A. I'll give you the same advice I give everyone. This is what I just sent out to my Comp 1511 students because they're halfway through an assignment. Best time to plant a tree is 20 years ago. Second best time is now. So I would figure out what you need to do. Not thinking about when it's due, but just think about what you need to do and knowing that you need to do it. the little bits. And there's always stuff that we forget. Sometimes we forget stuff intentionally because we're procrastinating and stuff, and say hit that stuff and just hit it now, try to get it over with. I know it's hard because we're in lockdown, we're at home, there's less that we can do to blow off steam and really kind of reset our brains and get them going. But yeah, I would say break things into as small chunks as you can and just do those things. And know that this is a piece of advice I was given when I was starting my thesis, and it works just as well partway through your thesis, is that I said this before as well, finished is better than good. Cut stuff out of your thesis if you're running out of time. So make it so that you are doing some research that gives you an answer at the end, rather than trying to do too much, running out of time, and ending up with something that doesn't give any answers because it reached too far and didn't make it there. So that's my advice for someone who's like halfway through Thesis B and is feeling like they're not going to get to the end. Replan an end point if you want to. So you could say, we're not going to do all the things that I said I was going to do initially. But if I do half of the things that I was going to do initially, I can still get some research output out of this. I'm still going to create something new and be able to test it. It can happen, and it's okay to do that if you have to. Finished is always better. Oh, finished is infinitely better than overreaching and unfinished. And that's pretty obvious, right? Overreaching and unfinished might as well be nothing. But unambitious finished is still finished, and it still helps. It's still furthering the knowledge of humankind. Someone who thinks that they figured out a way to make humans fly, jumps off a cliff, and then lands at the bottom, and all their ideas disappear with them, is not very useful. Whereas someone who thinks that they could figure out a way to get humans to fly, does a series of tests where you just jump off small objects and don't hurt yourself that much, at least has something to offer. It's not very much because humans can't fly, but at least they're offering something, you know? Sam said, simple question, but can you do a thesis after a computer science degree? I assume you can, but it's different to engineering. Yes, I talk in an engineering sense because computer science is very, very closely linked to the idea of engineering. A computer science graduate will get hired as a software engineer. So it's really funny because we teach students how to engineer even when they're in a science degree, which is a little bit different to, I think, the really strong split between science and engineering that might exist in other parts of the uni. Computing is so practical that we consider a computer science degree to be a mini engineering degree anyway. But even if you're just doing a computer science degree, Sam, you can enroll in a thesis after you finish your comp sci degree. So at the end of your 3 years of comp sci, yours is combined anyway, but at the end of the 3 years, you could apply for honours. Nerdy Gamer Geek says, what classes would you recommend in undergrad to prepare for honours research? That is very difficult for me to recommend because I would recommend the subjects that support the field of research that you want to go into. So I can't really guarantee one way or the other which subjects that is. You can work backwards from an ideal topic that you want to go into and say, I want to do blockchain. So if I want to do blockchain, I've got to do some stuff in crypto and security. I've got to do other stuff in data manipulation, maybe. Again, this is a very bad example because I've picked blockchain again, which I know nothing about. Oh, hello. I think it's time for our special guest to say hello. I think this is what everyone was here for. Anyway. Hello, little one. Come on. She's been asleep on the bed all day because that's what she does. But it's getting later into the afternoon. As it gets darker, she thinks it's feeding time, so she'll come around and say hello and stuff. So there you go. She's on the desk there. Okay. So that was Nerdy Gamer Geek was asking what classes to recommend in undergrad to prepare for honours research. Sometimes that's a good way to do it, but sometimes there's another way to think about it, is do the classes in undergrad that are the most exciting to you, and they will lead you to your honors research. So when I was in undergrad, like around third year and stuff, I did I did a big grab bag of subjects. Like second year, third year, I did networks, um, operating systems, um, some logic and stuff like that. So I did some stuff from maths as well as electives and things. Um, but I ended up um, really clicking with graphics. So I didn't do graphics until I got a mark in operating systems that suggested to me that I didn't want to do advanced operating systems. So I nearly went off in a um, completely different direction, where I said if I get a certain mark in operating systems, I'm going to do advanced operating systems. And because I didn't get the mark I set for myself there, I decided not to do it, and I took up graphics instead. And ended up doing, at the time we had graphics and advanced graphics, and I did a thesis in graphics. And at the same time, I was doing machine learning neural networks and all these logic programming subjects and things like that. And so I combined them together into an AI driven graphics project. So I only ended up in my thesis because I discovered these things on my way through. So I didn't necessarily plan for it to go a certain way and then pick the subjects that were going to fit that plan. I let it happen the way it was going to happen. Um, but Blaze is offering some useful advice, maybe. Do courses related to what you're interested in so you don't have to cram prereqs content in Thesis A. Yeah, you kind of don't want to be having to learn about it at the same time as you're supposed to be writing your literature review on it. You want to have learnt the basics in a course already, so that when you read the papers about it, they're more advanced than those basics, and then you can continue on. Because even a third year, fourth year course might not even be um, high end research or anything. It might still be introductory into a particular field. Um, Arthur's asking if you have to do courses directly related to your thesis. You could talk to a supervisor about that kind of thing. Because I've seen people look at trying to do theses that are related to a specific topic, but they don't realize that they haven't done the groundwork necessary to understand it. And that can be difficult. Like, there's ways to do it. And you can find your way around the lack of specific technical knowledge in things. You can research things that aren't necessarily the direct doing of the thing, but analyzing the data that comes out of the thing is still something that you could do, that kind of thing. But as Blaze is saying, you're going to learn things in your thesis A because you're going to read all these papers, and if you can understand enough from those papers, you can just jump in at that point. I mean, this is exactly how research works. Is like, if we were wanting to do computing research, and I said to everyone, you have to learn how to build a computer first. So people suddenly go into materials science to learn about silicon manufacturing and things like that. I would consider that a huge waste of time, right? So we want to skip that. We want to skip very well past that to where the current research is. And in the same way, some courses you may not need because you can skip all the way to them. Someone was also talking there about not wanting to have to do everything at the same time as Thesis A. So around the time of my thesis, I was in a 4-year engineering degree and I finished it in 5 years. So when I got to my 4th year, I realized that if I just cut back on a few things, I will do less subjects per term and I will be able to do my thesis with less distractions. I'm not saying that you have to do that, right? That's just a tactic. But for me, it turned me from a good distinction average student to a high distinction average student. Um, because when I was focusing on less things at a time, I got better at them. That doesn't work for everyone. Some people need a lot of work to be able to keep up their commitment to the work. Some people need less work to be able to survive the work. So obviously I'm much more a chill learner than a focused learner. I'm not a focused person in general. So when I had less things to do, I could go deeper into those individual things. And so the thesis is something like that. I mean, like if you were going to do something like a PhD, you don't do You don't have a whole subject load ticking along while you're doing the PhD. You just focus entirely on it. And so whether you want to do that or not, it's up to you. I don't want to tell people to take time off their course or anything like that. But there's a whole lot of tactics and strategy about how to succeed at a university that a lot of people are not going to explicitly talk about because they're about modifying your program from the standard path. But sometimes there are ways to do that can be to your advantage. Other questions? No, I just got up to the section in chat where everyone noticed the chicken appeared. She's she's still here. She's just sitting down there, as you can probably still hear her. Yeah, Ada said that you joined at the right moment. Yeah. Sam saying a bit of a tangent, but as you only have so many CS electives because you're combined, is it better to do a specialization or just a bunch of interesting subjects due to the double degree structure? I would never want, because I don't know you that well, Sam. Like I remember your name from, I think you were in last term's Comp 1511, I think. And I don't know enough about what you want to do with your life to give you that kind of advice. But I can tell you how to advise yourself on that. So what I would do, and this is what I like to do, like pretty much, I would say once a year, I would do this. I would sit down and I would say to myself, or I would write it down, depending on what, how you like to think about things. But I would say, what do I want to do with my life? So what are the things that are important to me? What are the things that make me fulfilled? What are the things that make me happy? One of them's right here, so that's real easy. Just making little beeping noises. Yes. So Chicken says, think about the things that you want to do. Think about the things that are going to fulfill you and make you happy. Aim towards those things, and then figure out what path you want to be on that's going to take you in that direction. Because that is the key, more than anything else. I'm not going to say that there's one way to do things. Like if you want to just game the system and say, what is the way to get the highest possible marks in a degree at UNSW? Well, you pick electives that everyone says is easier, and you do those. Or you pick electives that you know are enormously hard, but everyone gets scaled up in doing them, and people drop out a lot. So, yeah, you could do stuff like that, and you could game the marks, I think. I actually don't know if this works, obviously. It's been a long time since I've been a student. But those are the kinds of tactics that people might use to try to gain marks. Like, look at the previous assignments in other subjects and see if there's stuff that you can already do, and then pick subjects where you can already do them so that you get better marks. And you can see the disdain I have for this approach. Because if you just pick subjects where you already know how to do stuff, you learn nothing. So you come out of it with an empty degree with really high marks. And then when it comes down to it, future in life, you're just kind of like, oh, I don't know how to do anything. But anyway, you can try to commit like that or not. But I think that the better way to go through life is to think about what you want from your life, which often is very difficult, right? Because sometimes it's a matter of thinking, I would like the world to be a better place, but I have no choice but to live in the one that we're in. So it's difficult because what you need to figure out is, okay, what can I do in this situation? Which parts of this can I have control over? Can I change? Can I sculpt a path for myself that's going to get me at least closer to this goal that I'm looking at? And you go, okay, then we judge things back and forth based on whether they're going to get us towards our goals or not. So this is exactly the same as, where was it? When you write chapters, you see that each of them's focused on different things, choosing subjects, but all of them have to get back to this main point. So your main point is your main goal in life. And it doesn't have to be the same, right? It can shift from year to year. No worries about that, because as you learn more, you're going to shift it, especially academically. At the end of your first year, you can be like, okay, I want to do this. And the end of your second year, it's like, oh, I discovered this new thing. It's completely different to my previous goals, but I want to see where this goes. And then at the end of the third year, you can go, I failed it. Failed really badly at the continuation of that path, but I discovered something else. So now I want to try this direction, you know? And you'll hit a point, if you're going to do a thesis, you'll hit a point when you're on approach to that thesis where you'll know that you've got a certain expertise and a certain way of doing things. And then you can pick where you want to go from there. But yeah, so whether to take subjects in a broad range or a specialization, it's a difficult call, and it depends on what you want to do. I know people who are currently studying at CSE who have picked courses outside of their degree. So they've just said, you know what, I'm going to load up some hex debt because this course does not count for my degree, but I'm going to do it anyway because I think that there's something in that I want to learn from. And when we start to think of things like that, we can think of university as a place where you pay money for knowledge. And it's not even that bad sometimes, because sometimes it's future money. And if you think that that knowledge, this is also a very horrible way to think about these, but anyway, if you think that that future money that you're going to be able to make will be improved by you getting this knowledge, then it doesn't matter if it doesn't fit your degree. The degree is an arbitrary concept. It's not the same as the knowledge that you take when you leave university and are able to use. So you can think about things that way if you want to. It's tough, you know, all this stuff I'm saying, none of it is 100% true. None of it is the best advice possible, but it's stuff that you can think about that may be able to get you somewhere, you know. So that's how I'm giving this kind of advice. Yeah, so that was Sam's question about specialization and stuff. Double degrees make it difficult, yeah. If you can find something that ties into both, then that could be really good. Sam's also thinking of changing out of commerce to do economics and into maths, but another conversation, yeah. Also, a very difficult conversation to have with someone like me, because I started in a software engineering degree straight out of high school, and then I finished in that degree. So I didn't take any of the advice that I give nowadays, apart from like underloading at the end of my degree. I took very little of that advice and didn't explore very much. Finished, and then started exploring afterwards. So I spent a couple of years saying adamantly that I would never work in the computing industry, and that didn't entirely work. I got dragged back in, but I did a bunch of other stuff, and it was interesting to see what other options there could have been in life, and whether you want to do that during your university years in an academic sense or at another time and stuff, or maybe you've done gap years and stuff beforehand to learn about things. Like, all of that stuff can help. It's hard to say exactly how. Blaze said, "This is the first time you've heard me talk. I'm inspirational." Thank you very much, Blaze. That's very nice to hear. I guess the way that I like to talk about my rationale for how I want to teach people is that the subject matter is just bullshit. It's just technical stuff. You can learn that yourself. If I sent everyone in Comp 1511 to a set of videos on how to write C and then threw them in the exam at the end, there's a significant bunch of them that would be fine. But what's more important is to give people the ability to learn for themselves eventually. And that's a really wide concept, you know. Teaching people how to learn is super, super difficult, because partly it's like, what is the mindset necessarily to learn? What confidence level do people need in themselves to be able to learn, and other things like that. So the whole idea of trying to be inspirational to people turns out to be something that's really useful. Because if I can convince people that they can do anything that they set their minds to, then more of them are going to be able to do that stuff than could before I'd said that. And I don't even need to teach people how to program. If I can teach them that they could learn how to program without me, then more of them, I think, are going to end up knowing how to program than if I only taught programming. Because if I only taught programming and nothing else, then people just get bored and they're just like, whatever's, you know, and then they don't learn. And I think it's also a really beautiful thing, because university, it was a great time for me as well. I loved university. I'm still here 20 years later. I came back to UNSW because I love the place so much. Um, I think the time in university is a time of both great freedom and incredible hardship. Because it's like freedom, you can do all this kind of cool stuff. There's a whole bunch of like people here who run different societies. I can see like Google the Google Society, the Google Student Society here. I can see CSC Soc here. Obviously, CSC Soc here, they ran this. And there's people that run other things. And then none of the people are doing these things for academic credit or for pay or anything. They're doing it because it interests them. You have this freedom to try out these things. These things can also put massive burdens on you, which is a good and bad thing because those burdens can teach you how to handle difficult work. What is the chicken? Chicken really appreciates this point, by the way. So she's trying to add her knowledge, her extensive knowledge of hardship and suffering, and her hardship and suffering is the fact that I'm not feeding her right now. I think is like the hardship, but you can learn a lot from that because like I did CSE review back at the very beginning. I was one of the first people in the CSE review actually. It's I managed a budget of about $30,000 and about 100 people when I was one of the producers of CSE review, and at no point is a student usually given that kind of responsibility. Um, but I think I learned more about managing people there, and also in playing World of Warcraft than I did from any of my courses. So I think that the embracing of this kind of freedom and this ability to like put yourself through some really interesting, difficult situations um, can teach you a lot. There's a lot to learn at university that's well above and beyond what's in the subjects. Um, and so that when I'm teaching students, I try to bring a little bit of that in. That yes, there are subjects, yes, there are marks, but they're all bullshit. and and what's really important is what else you can learn. So thank you very much for the compliment. Um, Henry said, "Does this also apply to degrees and changing degrees? Currently thinking of changing degrees at the moment." Yes, 100%, Henry. Um, Sticking to one degree is possible. Um, if you haven't heard of the US system, I don't know if all US universities do this, but they have 1 year of general education before you pick your degree as such. So basically, they have 1 year where you learn lots from all these different fields, and then you see if you were inspired by a particular field, and then you transfer into that. Um, Uni of New South Wales doesn't necessarily do that, but they do it in a small scale. In that, for example, me teaching Comp 1511 does convince some people every time I do it. Some people find out that computing is something interesting to them, and then they transfer into computing. And a lot of people will do it in their first year in other engineering fields, other science fields, and other maths fields and stuff like that. So a lot of the STEM courses are going to do a basic computing course, and so some people then will figure out, oh, okay, maybe I do this rather than what I enrolled in originally, and that's totally fine. You can jump between degrees without losing a lot of credit as you do it. You could even, don't quote me on this because I don't know for certain, but I think you could jump into a degree and then jump back, and you'd still have all the credit that you'd earned in all the subjects that you did. So I think it's, yeah, because I've seen people do one degree, get to the very end of it, and then when they graduate, they say, "Oh, I graduated from a different degree. I realized I had all of my subjects lined up to fill out a different degree." So it's like I got to the end of this, and I did so many electives in physics. It turns out I have a physics degree, not a computer science degree. And I was like, okay. And so, what do you want to do with that? And it's like, I don't know. So it's like you can say like, so this person was like, I decided I wanted to be a physicist. Like, yes, I know all this computing stuff, which means I can write programs to do physics, which is great. But I realized that all my subjects fit this other thing, so it's cool, you know. Michael didn't realize that CSE Review had that much money. CSE Review does not have that much money. That was back in the day when the CompSoc, the computing society at the time, didn't have the relationship with the sponsors that we did. So we reached out to the sponsors and they were willing to give money. Whereas now the sponsors, I think, are more willing to give money to the student society as a whole, which is probably, I don't know, I don't want to take sides. I guess it's probably better because it gives services to more students. Back then, CSE Review was like building what you would consider to be the framework um, for how student societies in CSC kind of are nowadays. So we were the first to do any kind of, we weren't the first. Comsoc was doing way more stuff before we were doing it, but I think, I don't know, we brought a new bunch of people in a different way to get lots of people involved, and then everyone got involved in lots of things in CSE. So I think that's like when things changed for us, that doesn't necessarily mean that there weren't always societies doing interesting things. I don't know. I'm sure it's like, I'm thinking like, memory from like 20 years ago. It's not going to be that accurate anyway. Okay, so Henry was saying thanks. Still trying to decide if you switch to CS from ChemEng. Yeah, it's a tough call. Um, if I were you, I'd spend some time thinking about what you want to do, um, and how much inspiration you draw from the different subjects you're doing, because it really is, it's not a matter of how good you are at something, because how good you are at something changes over time, but it's how much it wants you to care about it. And you'll find that like you will care more about some subjects than other subjects just from the doing of it. And I think that people need to make decisions on subjects based on, like, it's heart rather than head, because you can't control your heart, but your head you can just learn new things. But if you really love something, it's more important to get involved with that than just picking something that you're maybe better at or something, because being better at something is really, it's really ephemeral. Like, it's only going to last a little while. But the the caring about something long term is how you end up much better at it long term. Okay. So Donna says, Blaze. Oh yeah, I am actually doing a lecture tomorrow, 4 to 6 p.m. It's just a Comp 1511, but it's about professionalism. I did give it last term open to all of CSESOC, but you can totally come along if you check the Comp 1511 webpage. I'll be putting the live stream up later today, so you can come along and watch that one as well. Sam knows what you want to do, but it takes 5 undergrad degrees or more. Turns out you want to be Leonardo da Vinci, the the Renaissance. What do they call him? The philosopher king that can do everything. I don't know if you necessarily want to do military there, but like that kind of thing of like someone who wants to learn everything. Do we still do liberal arts degrees? I remember seeing that, which was like a degree that you can literally take electives from anywhere in the university. You could do one of those and just do it for like 8 years. Or do several separate degrees. I've seen people do that as well. Do like 2 or 3 undergrad degrees. But I don't know. Hard to advise you on that, Sam. As I said before, I think it's going to be a matter of you figuring out what your path is going to be, and allowing it to evolve into different things as you go along it. Yeah, just be the avatar. Sadly, most of us cannot be the avatar. In fact, most of us are sucker because he's the one that doesn't have any magic powers, and none of us have magic powers either. Okay, I should wrap it up now because, yeah, and Blaze is saying the same thing. You find halfway through the degree that you don't like it. I found out halfway through my software engineering degree I didn't like it, so I'm not sure how I finished. I was going to quit and go do sound engineering because I was a musician and music producer, and I recorded a few other people's bands and stuff like that. So I had all of the backing to go off into doing that, but I'm not sure why. I just didn't end up doing it. And then somewhere along the way, I hit the third year computing and later computing subjects that were really specialized into particular things, and I realized I could go deep into each of those, and then I got like hooked back into computing. And so it was really funny because I think I was like, first year I was like, I don't know, credit student. Second year I was like barely passing, failed a subject and stuff. And then third, fourth, and fifth year I was an HD student. So it was just, I was just trying to find the right part of computing for me to actually enjoy it. So interesting. You may find yourself going on a different path or even a similar path as that. I'm sure there's plenty of people who are going to be in that kind of situation. But I think we've wrapped up because I think there's no more questions here. I think I've gone way off the technical writing questions now, and we're just talking about what do we want to do to make our time in the university better, and what do we want to do so that we can like sort of enrich our lives with our education. So I think we should wrap it up there. Thank you all for coming along. This whole stream has been recorded on my YouTube, so as opposed to the kind of random chill out stream that I did last week, I'm going to save this one. Oh, someone is trying to tell me that she wants to eat food, so I should go off and feed her as well. Yeah, so I'll wrap this up, but the recording will be up there in case anyone wants it afterwards. So thank you all for coming along. I hope that at least the first 2 hours of this gives you some useful advice for doing stuff like writing for your thesis if you need it. And I will... Henry's asking if I'm going to do another chill out stream with Daniel this week. I don't think Daniel's streaming this week. He definitely didn't last Friday. We'll see. I may do a chill out stream, but I might also be a bit busy. If I do, I'll throw it up public on my channel anyway. Michael, I am going to make this video public, yeah, so you can share it around. Okay. See you all soon. Yes. And thank you, chicken.